Mastering SAP BW for HANA. 50. Advanced Data Modeling Interview Scenarios. What if the secret to acing your SAP BW for HANA data modeling interview lies in understanding the subtle nuances of its most advanced features? Many candidates stumble when faced with scenarios involving complex composite providers or intricate open ODS view integrations. Discover the precise strategies and expert insights to tackle these high-stakes questions head-on, turning potential pitfalls into opportunity to showcase your deep expertise. This is not a BW for HANA tutorial. This is not certification preparation. And this is not about memorizing objects. This video is about judgment, the kind of judgment interviewers look for when hiring senior BW for HANA engineers and architects. Most candidates fail BW for HANA interviews not because they don't know a DSOs or composite providers, but because they cannot explain why one design survives production while another collapses at scale. That is exactly what this video teaches.
How this video is structured.
We will walk through 50 real interview scenarios used in modern BW for HANA interviews. These are not exam questions. They are design conversations disguised as questions, testing architectural thinking rather than syntax.
The three-part masterclass structure. How we divided 50 scenarios.
Part 1, the brain, advanced modeling and architecture judgment, 30 scenarios. Part 2, the veins, data provisioning and extraction reality, 10 scenarios. Part 3, the muscle, performance, migration and operations, 10 scenarios. Each part builds on the previous one. We start with design thinking, move into how data actually enters BW for HANA, and finish with how systems behave under load, scale, and change.
Part 1, the brain, advanced modeling.
Part 1 focuses on the most misunderstood area of BW for HANA interviews, modeling decisions. Not how to build models, but why certain models exist at all. This is where interviewers decide whether you think like a BW developer or like a BW for HANA architect.
How Part 1 is organized.
The first 30 scenarios are grouped into 5 architectural categories. Each category tests a different dimension of BW for HANA judgment, moving from object fundamentals to full architectural redesign thinking.
Part 1 category map.
Category 1, core BW for HANA modeling decisions, 6 scenarios. Category 2, advanced ADSO design and data flow, 6 scenarios. Category 3, composite providers and virtual modeling, 6 scenarios. Category 4, open ODS views and external data, 6 scenarios. Category 5, modeling trade-offs and architecture judgment, 6 scenarios.
Category 1, core BW for HANA modeling decisions.
This category tests whether you understand why BW for HANA exists at all, not just how to use its objects. Interviewers use these questions to immediately separate candidates who still model like classic BW from those who truly understand the HANA-first mindset.
Category 1 scenarios covered.
1. Why InfoCubes are no longer used in BW for HANA. 2. When to choose a standard ADSO versus a right-optimized ADSO. 3. Why modern models avoid multi-layered transformations. 4. What replaces classic LSA in BW for HANA. 5. When a composite provider is better than a multi-provider. 6. Whether reporting should sit on a DSOs or composite providers. These questions look simple, but they are designed to expose weak architectural thinking very quickly.
Scenario 1. Why not use InfoCubes in BW for HANA?
In classic SAP BW, the InfoCube was the foundation of reporting. In BW for HANA, InfoCubes are obsolete and replaced by a DSOs. The interviewer asks, why did SAP remove InfoCubes? Did BW for HANA sacrifice multidimensional performance, or was the old design fundamentally flawed?
What most candidates say, and why it's weak.
Most candidates respond, InfoCubes are deprecated, so we use a DSOs. A DSOs are faster because BW for HANA runs on HANA. This answer is weak because it avoids the real architectural reason. It does not explain the extended star schema, the SID and dimension table overhead, or why those structures existed in the first place.
The interview-winning answer.
InfoCubes were designed to compensate for limitations of row-based databases. In BW for HANA, those compensations become liabilities. 1. Extended star schema overhead. InfoCubes rely on dimension tables and SIDs to optimize joins on row-based databases. On HANA, these joins add unnecessary CPU and memory overhead. 2. Columnar storage advantage. HANA reads columnar data efficiently without pre-aggregation, making flat tables faster for both reads and writes. 3. Write performance. InfoCubes require SID generation and dimension lookups during load, increasing activation time. ADSOs write data directly into flat tables. 4. Modeling flexibility. Changing an InfoCube often required remodeling dimensions. And a DSO change is a simple column extension, enabling agile modeling. InfoCubes were not removed because they were old, but because their core design conflicts with how HANA processes data. Here is SQL architecture comparison showing why a DSO flat axis outperforms InfoCube star schema. Disclaimer: always test code in a non-production environment. This demonstrates the architectural shift. By persisting data in a flat table, the ADSO allows the HANA engine to perform a direct columnar scan. There are no dimension joins or SID lookups at query time, which eliminates join-heavy bottlenecks and allows the query to scale across millions of records with sub-second response times.
Follow-up 1, mid-level. If ADSOs are flat, do we lose SID-based master data handling completely?
Answer: no. ADSOs can still generate SIDs if master data checks are enabled. However, in BW for HANA, we deliberately disable SIDs for high cardinality fields to improve load speed and rely on query-time joins only when business semantics require it.
Follow-up 2, senior level. How do you migrate a large InfoCube to BW for HANA with zero reporting downtime?
Answer: a common approach is shell conversion. The ADSO structure is created first, historical data remains in the InfoCube, and a composite provider unions old and new data. New loads go to the ADSO while reporting continues uninterrupted.
Follow-up 3, curveball. After replacing an InfoCube with an ADSO, high cardinality navigation becomes slower. Why?
Answer: this usually happens because the InfoCube benefited from indexed SIDs by default. In a flat ADSO, high cardinality columns may require explicit secondary indexes at the HANA level to optimize joins and navigation performance.
Key takeaway.
InfoCubes solve problems of slow disks and row-based databases. BW for HANA removes those problems, making flat ADSOs the superior and simpler design.
Exclusive pro tip.
Inventory InfoCubes cannot be converted to standard ADSOs without enabling the inventory, non-cumulative property. Missing this step breaks historical stock calculations during migration.
Scenario 2. When should you use a standard ADSO versus write-optimized ADSO?
You are designing an inbound layer to ingest 100 million IoT sensor records per day. The business requires extremely fast ingestion and downstream delta capability, but the source system does not provide a reliable timestamp or delta pointer. The interviewer asks, which ADSO type do you choose and why?
What most candidates say and why it's weak.
Most candidates say, use a standard ADSO because it has a change log, or use a write-optimized ADSO because it is faster. This answer is weak because it treats ADSO types as a toggle instead of a lifecycle decision. A standard ADSO will collapse under activation and SID generation at this volume, while a simple write-optimized ADSO cannot provide a meaningful delta for downstream layers if the source has no timestamps.
The interview-winning answer.
I would deliberately split ingestion speed from business processing using a two-tier LSA++ design. 1. Tier 1. Ingestion layer. Use a write-optimized ADSO with no activation and no SIDs to absorb 100 million plus records daily at maximum insert speed. 2. Synthetic delta enablement. Enable request-based delta on the write-optimized ADSO so downstream layers can reliably consume new load requests. 3. Tier 2 processing layer. Load into a standard ADSO where activation, deduplication, semantic keys, and change log logic are applied in controlled micro-batches. This architecture decouples ingestion velocity from data correctness and reporting stability. HANA SQL. enabling high-volume ingestion on a write-optimized DSO. Disclaimer: always test code in a non-production environment. This code configures physical hash partitioning on the write-optimized DSO. By partitioning on the technical request timestamp, parallel insert operations are distributed across partitions, eliminating hot blocks and maximizing ingestion throughput under extreme data volumes. This predicate shows how a synthetic delta is created. Since the source system provides no delta pointer, downstream layers track the last processed request timestamp and only consume newer records, ensuring deterministic delta propagation.
Follow-up 1, mid-level. Why not skip the write-optimized DSO and load directly into a standard DSO?
Answer: at this scale, activation becomes the bottleneck. Standard DSOs require SID generation, semantic key checks, and change log population during activation. This introduces locking and CPU pressure that will delay or even block continuous ingestion.
Follow-up 2, senior level. The IoT source sends duplicate records. How is this handled?
Answer: write-optimized DSOs accept duplicates because they rely on technical keys. Deduplication is intentionally deferred to the transformation into the standard DSO, where overwrite logic or SQL script aggregation can enforce business keys deterministically.
Follow-up 3, curveball. GDPR requires deleting specific sensor records. What is the impact?
Answer: selective deletion on a write-optimized DSO is expensive and does not immediately reclaim space. For compliance-heavy scenarios, data should be periodically rolled into a standard DSO or partitioned by time so entire partitions can be dropped efficiently.
Key takeaway.
Write-optimized DSOs are ingestion engines, not reporting objects. Standard DSOs are correctness engines. High-volume BW4 HANA models work only when these responsibilities are separated.
Exclusive pro tip.
For extreme volumes, combine write-optimized DSOs with semantic time partitioning. This allows old partitions to be dropped instead of deleted, keeping the active table lean and query plans stable.
Scenario 3. Why do modern BW4 HANA models avoid multi-layered transformations?
In classic BW systems, data flowed through many layers, PSA to DSO to InfoCube to aggregate. In BW4 HANA interviews, a common question is, why do modern BW4 HANA models deliberately reduce the number of transformation layers? Isn't layering good design?
What most candidates say, and why it's weak.
Most candidates answer because HANA is fast, we don't need many layers anymore. Why this is weak: it sounds correct but shallow. It ignores where performance is gained and what is lost with excessive layering. It also fails to explain the operational cost, longer load chains, higher failure points, and unnecessary data movement inside HANA.
The interview-winning answer.
Modern BW4 HANA models avoid excessive layers because layering solves problems that no longer exist while creating new ones. 1. Layering was designed to compensate for slow databases. Each layer reduced joins or pre-aggregated data. HANA's columnar engine removes that need. 2. Every transformation physically moves data, consuming memory, CPU, and load window time without adding business value. 3. Multiple layers make root cause analysis harder. A single data error propagates through several DSOs, increasing recovery time. 4. Fewer layers push logic closer to consumption, allowing HANA pushdown, filters, joins, aggregations to execute once instead of repeatedly. In BW4 HANA, fewer layers mean less data movement, simpler operations, and better end-to-end performance.
Follow-up 1, mid-level. Does this mean LSA++ is dead, and we should always use a single DSO?
Answer: no. LSA++ is still relevant, but it is applied selectively. We keep layers only when they serve a clear purpose, such as raw data retention, harmonization across sources, or audit requirements. The difference is that layers must justify their existence.
Follow-up 2, senior level. When would you intentionally keep an extra transformation layer in BW4 HANA?
Answer: I would keep an extra layer when data harmonization is complex. For example, combining multiple source systems with different semantics, currencies, or calendars. In such cases, the harmonization layer isolates complexity and protects reporting stability.
Follow-up 3 Curveball. A system with only 2 layers still performs poorly. What could be wrong?
Answer: the issue may not be layering but data volume, poor partitioning, missing filters in composite providers, or heavy runtime joins. Reducing layers helps, but performance still depends on modeling discipline and data access patterns.
Key takeaway.
BW4 HANA is not about removing layers blindly. It is about removing layers that only exist to compensate for old database limitations. Each remaining layer must deliver clear architectural value.
Exclusive pro tip.
If a transformation does nothing more than field-to-field mapping, it is usually a candidate for removal. That logic almost always belongs in a composite provider or directly in the consuming query instead.
Scenario 4. What replaces classic LSA in BW4 HANA?
In classic BW, the layered scalable architecture, LSA, enforce strict layers like PSA, corporate memory, data mart, and reporting. In BW4 HANA interviews, you are often asked, does LSA still apply, or has SAP completely replaced it with something new?
What most candidates say, and why it's weak.
Most candidates say LSA is replaced by LSA++ in BW4 HANA. Why this is weak? This answer repeats a buzzword without explaining what actually changed. It does not explain why classic LSA fails on HANA, nor how LSA++ changes design decisions around persistence, transformations, and reporting.
The interview-winning answer.
Classic LSA is not replaced, but fundamentally reinterpreted in BW4 HANA as LSA++1. Classic LSA was designed to minimize database load by pre-aggregating and separating concerns into rigid layers. 2. In BW4 HANA, HANA's in-memory processing removes the need for many intermediate persistence layers. 3. LSA++ keeps the architectural intent, raw data, harmonization, reporting, but collapses unnecessary layers. 4. Instead of many DSOs and transformations, BW4 HANA uses fewer ADSOs combined via composite providers. 5. The focus shifts from data staging to logical modeling and push-down execution at query time. LSA++ preserves architectural discipline without the operational overhead of classic LSA.
Follow-up 1 Mid-level. Does LSA++ mean we no longer need a corporate memory layer?
Answer: no. Corporate memory still exists conceptually, but it is often implemented as a single raw DSO instead of multiple persistent layers. The difference is that retention is intentional, not automatic.
Follow-up 2 Senior level. What risks appear if LSA++ is misunderstood?
Answer: teams may remove too many layers and mix raw, harmonized, and reporting logic into a single ADSO. This creates fragile models that are hard to change, test, and audit over time.
Follow-up 3 Curveball. Can you implement LSA++ without composite providers?
Answer: technically yes, but it defeats the purpose. Composite providers are a core enabler of LSA++ because they allow logical layering without physical data duplication.
Key takeaway.
LSA++ is not about fewer objects. It is about fewer unnecessary objects. Architecture still matters, but it must align with HANA's strengths.
Exclusive pro tip.
If your BW4 HANA system still mirrors the same number of layers as classic BW, you are likely carrying historical design debt that HANA no longer requires.
Scenario 5. When is a composite provider better than a multi-provider?
In classic BW, the multi-provider was the standard way to combine data from multiple info providers. In BW4 HANA interviews, a common question is, why did SAP introduce composite providers, and when should you choose them over multi-providers?
What most candidates say, and why it's weak.
Most candidates say composite providers are the new version of multi-providers. Why this is weak? This answer only states replacement, not capability. It ignores the most important difference. Multi-providers only support union operations, while composite providers introduce join logic and push computation down to HANA.
The interview-winning answer.
A composite provider is better than a multi-provider when you need flexibility, pushdown, and runtime logic. 1. Multi-providers only union data sets. They cannot join data across providers, which forces pre-joining and persistence. 2. Composite providers support both union and join operations, allowing real-time combination of facts and master data. 3. Joins in composite providers are executed in HANA, enabling pushdown of filters and aggregations. 4. Composite providers reduce data duplication by avoiding additional DSOs created only for reporting purposes. 5. They allow logical modeling, where structure can change without reloading data. Composite providers replace multi-providers because they enable logic at runtime instead of forcing persistence.
Follow-up 1, mid-level. Can composite providers fully replace multi-providers in all cases?
Answer: yes, from a functional perspective. However, you must still consider performance and data volume. Poorly designed joins on large DSOs can degrade query performance if filters are not pushed correctly.
Follow-up 2, senior level. When would you still avoid joins in a composite provider?
Answer: I would avoid joins when joining very large fact tables at query time. In such cases, pre-aggregation or persistence may still be required to protect query SLAs.
Follow-up 3, curveball. A composite provider query is slow even though HANA is fast. Why?
Answer: the issue is usually missing filters, incorrect join cardinality, or mismatched granularities. HANA executes joins quickly, but only when the model enforces correct semantics and selectivity.
Key takeaway.
Multi-providers combine data. Composite providers model logic. BW4 HANA favors logical modeling over physical persistence.
Exclusive pro tip.
Always define join cardinality explicitly in composite providers. Incorrect cardinality prevents filter pushdown and is one of the most common causes of poor BW4 HANA query performance.
Scenario 6. Should reporting sit on a DSOs or composite providers?
In BW4 HANA projects, teams often debate where reporting should be built. An interviewer asks, should queries run directly on a DSOs for performance, or should they always sit on composite providers? This question tests whether you understand separation of concerns in modern BW architecture.
What most candidates say and why it's weak.
Most candidates say reporting should always sit on composite providers because that is the new best practice. Why this is weak? This answer blindly follows guidelines without context. It ignores performance-sensitive scenarios, operational reporting needs, and the cost of unnecessary abstraction layers.
The interview-winning answer.
The correct answer depends on the purpose of reporting and the stability of the model one. For enterprise reporting, queries should sit on composite providers to isolate reporting from data persistence and allow flexible modeling. 2. For operational or real-time reporting, queries can run directly on a DSOs to minimize runtime joins and latency. 3. Composite providers protect reporting from structural changes in a DSOs, reducing rework during model evolution. 4. Direct DSO reporting is acceptable when the data model is stable, well-indexed, and tightly controlled. 5. A hybrid approach is common, a DSOs for operational dashboards, composite providers for analytical reporting. BW4 HANA architecture favors flexibility first, but never at the cost of critical performance SLAs.
Follow-up 1, mid-level. Why is direct DSO reporting considered risky in large programs?
Answer: because changes to the DSO structure directly impact queries. Without a composite provider, even small changes like adding a field can break reporting or require mass query adjustments.
Follow-up 2, senior level. How do composite providers help during system migrations or redesigns?
Answer: they allow us to swap or union multiple data sources behind the scenes while keeping queries unchanged. This is critical during phased migrations or coexistence scenarios.
Follow-up 3, curveball. A report on a composite provider is slower than on the DSO. What do you do?
Answer: I analyze join paths, filters, and cardinality. If the composite provider adds unnecessary joins, I simplify it or selectively allow direct DSO reporting for that use case.
Key takeaway.
Composite providers are an architectural shield. Use them for flexibility and resilience, but allow direct DSO reporting when speed and simplicity matter most.
Exclusive pro tip.
In performance-critical scenarios, create a dedicated reporting DSO optimized for read access and expose it through a minimal composite provider. This preserves architecture without sacrificing speed.
Closing Category 1, From Objects to Data Flow.
Category 1 focused on choosing the right BW for HANA objects and understanding why modern BW architecture looks the way it does. At this stage, interviewers know you can model correctly. The next question is tougher. Can you make these models work reliably at scale, under real data pressure?
Please check description or comment section of this video. I have given a lot of links for downloading 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked, system design, most asked implementation project-related questions and answers, support project-related questions and answers. Required for your SAP technical modules interviews jobs like SAP Basis admin jobs, SAP S4 HANA consultant jobs, SAP ABAP developer jobs, SAP ABAP OData developer jobs, SAP Fiori UE5 developer jobs, SAP ABAP HR consultant jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem-solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people. Also for your interviews, you people can download all 8 PDFs in a single zip file from below given links.
Up next, Category 2, Advanced DSO Design and Data Flow.
In Category 2, we move from what object to choose to how data actually flows through BW for HANA. These scenarios test performance tuning, delta handling, activation behavior, and lifecycle decisions that only surface in real production systems.
Category 2, Advanced DSO Design and Data Flow.
Theme, performance, delta, and lifecycle thinking. This category evaluates whether you understand DSOs beyond checkboxes. Interviewers use these questions to identify candidates who have handled large volumes, real-time feeds, and production bottlenecks.
Category 2 Scenarios, 6 scenarios.
1. Why does activation become a bottleneck in a DSOs? 2. How do you design a DSOs for real-time or near real-time reporting? 3. When should you avoid change logs completely? 4. Handling late arriving data in BW for HANA models. 5. Delta handling when source systems don't support delta. 6. Why fewer DSOs can outperform clean layered models. These scenarios test whether you can keep BW for HANA fast, stable, and scalable once data volumes grow.
Scenario 7. Why does activation become a bottleneck in a DSOs?
In BW for HANA projects, teams often complain that data loading is fast, but activation takes hours. An interviewer asks, why does a DSO activation become a bottleneck even though HANA is fast? This scenario tests whether you understand what actually happens during activation.
What most candidates say and why it's weak.
Most candidates say activation is slow because of large data volume. Why this is weak, volume alone is not the reason. This answer ignores SID generation, change log writes, delta calculations, and table-level locking, the real causes of activation bottlenecks.
The interview-winning answer.
A DSO activation is expensive because it performs multiple system-critical operations. 1. During activation, data moves from the inbound table to the active table, which is a physical rewrite, not a metadata switch. 2. If SIDs are enabled, the system generates or validates SIDs for every characteristic, which is CPU intensive. 3. The change log is written during activation to support delta propagation, adding I or O overhead. 4. Activation holds locks on a DSO tables, which can block parallel loads and downstream processes. 5. Large request sizes amplify all of these costs, making activation the dominant bottleneck. Activation is slow not because HANA is weak, but because activation does much more than just move data.
Follow-up 1, mid-level. How do you reduce activation time without changing hardware?
Answer: I reduce request size by splitting loads into smaller packages, disable unnecessary SIDs, and review whether the change log is actually required for downstream delta.
Follow-up 2, senior level. When would you completely avoid activation?
Answer: for pure ingestion or staging layers, I would use write-optimized DSOs where no activation is required, and push activation logic downstream only where business rules are applied.
Follow-up 3, curveball. Activation is fast in QA but slow in production. Why?
Answer: production usually has higher data volume, concurrent loads, and active reporting. Table locks and SID contention appear only under real concurrency, not in isolated QA runs.
Key takeaway.
A DSO activation is a heavy operation involving data movement, SID processing, and delta tracking. Designing models that minimize activation is critical for scale.
Exclusive pro tip.
If activation dominates your load window, review whether the DSO truly needs to be standard. Many systems dramatically improve by converting early layers to write-optimized DSOs.
Scenario 8. How do you design a DSOs for real-time or near-real-time reporting?
In modern BW4 HANA landscapes, business users expect dashboards to update every few minutes or even seconds. An interviewer asks, how do you design a DSOs to support real-time or near-real-time reporting without destabilizing the system? This scenario tests whether you understand latency, locking, and load behavior under continuous data flow.
What most candidates say and why it's weak.
Most candidates say, use real-time data sources and schedule the load frequently. Why this is weak? This answer focuses only on scheduling. It ignores a DSO type selection, activation impact, locking behavior, and how continuous loads interact with reporting queries.
The interview-winning answer.
Real-time reporting works only when DSOs are designed to minimize contention and processing overhead. 1. Use write-optimized DSOs for the real-time ingestion layer to avoid activation locks and SID generation. 2. Keep request sizes small to reduce lock duration and avoid blocking concurrent reporting. 3. Avoid change logs in real-time layers unless delta propagation is strictly required. 4. Expose data to reporting via a composite provider to isolate ingestion from consumption. 5. Apply filters early in composite providers so reporting queries touch only recent data. Real-time reporting is an architectural decision, not just a scheduling setting.
Follow-up 1, mid-level. Can you run BW queries directly on a write-optimized DSO?
Answer: yes, but with caution. Write-optimized DSOs support read access, but they are not optimized for complex aggregations. They work best for operational dashboards with limited calculations.
Follow-up 2, senior level. How do you protect reporting queries during continuous loads?
Answer: I separate ingestion and reporting using composite providers, restrict query filters to recent partitions, and avoid long-running queries that scan the entire DSO.
Follow-up 3, curveball. Real-time loads are fast but queries still lag. Why?
Answer: the bottleneck is often query design, not loading. Missing filters, wide selections, or high cardinality characteristics can overwhelm reporting even if ingestion is near real-time.
Key takeaway.
Real-time reporting in BW4 HANA succeeds when ingestion is lightweight and reporting is logically separated. Mixing both in the same DSO leads to contention and instability.
Exclusive pro tip.
For near real-time use cases, combine write-optimized DSOs with time-based semantic partitioning. This allows reporting to target only the latest partitions, while older data remains untouched.
Scenario 9. When should you avoid changelogs completely?
In BW4 HANA, change logs are often enabled by default on standard DSOs. An interviewer asks, change logs support delta propagation, so why would you ever avoid them? When is enabling a change log actually harmful? This scenario tests whether you understand the cost of delta tracking.
What most candidates say and why it's weak.
Most candidates say change logs are required for deltas, so they should always be enabled. Why this is weak? This answer treats change logs as free. It ignores the write amplification, activation overhead, storage growth, and operational complexity introduced by change logs.
The interview-winning answer.
Change logs should be avoided when they add cost without delivering value. 1. Change logs duplicate data changes, effectively doubling write volume during activation. 2. For reporting only DSOs with no downstream targets, change logs provide no benefit. 3. High-frequency or real-time ingestion layers suffer when change logs are enabled due to increased I or O and locking. 4. Change logs grow rapidly and require housekeeping, increasing operational effort. 5. Delta can often be handled logically using request-based tracking or timestamps instead of change logs. Change logs are a powerful feature, but only when delta propagation is truly required.
Follow-up 1, mid-level. If you disable the changelog, how do you handle downstream deltas?
Answer: I use request-based deltas, timestamps, or full overwrite strategies depending on the downstream requirement. Delta does not always require a change log.
Follow-up 2, senior level. When is a change log non-negotiable?
Answer: when the DSO feeds multiple downstream targets that require consistent before and after images, such as financial deltas or reconciliation-sensitive processes.
Follow-up 3, curveball. Disabling changelogs improved load time, but reporting users complain. Why?
Answer: reporting issues usually arise because queries relied on delta semantics or time-based filtering that was implicitly provided by the change log. The model must be adjusted to compensate explicitly.
Key takeaway.
Change logs are not a default setting. They are a deliberate architectural choice that trades load performance for delta capability.
Exclusive pro tip.
Before enabling a change log, ask one question: who consumes this delta? If the answer is no one, disable it immediately.
Scenario 10. Handling late arriving data in BW4 HANA models.
In real production systems, data does not always arrive in order. An interviewer asks, what happens when transactional data arrives before its master data or reference attributes? How do you handle late arriving data without breaking reporting consistency? This scenario tests whether you understand data lifecycle and referential integrity in BW4 HANA.
What most candidates say and why it's weak.
Most candidates say, reload the data once master data arrives. Why this is weak? Reloading is expensive, operationally risky, and often impossible in near real-time systems. This answer ignores how BW4 HANA is designed to tolerate incomplete context at load time.
The interview-winning answer.
Late arriving data must be absorbed safely first, then corrected once context becomes available. 1. Load transactional data immediately into an ADSO, even if master data attributes are missing. 2. Use technical keys or business keys without enforcing SID checks at ingestion time. 3. Allow reporting to show placeholder or initial values instead of failing the load. 4. Once master data arrives, correct the records through a targeted update or overwrite strategy. 5. Avoid full reloads by designing models that expect temporal inconsistency. Late arriving data is a data design problem, not a scheduling problem. HANA SQL, correcting late arriving records without reloading data. Disclaimer: always test code in a non-production environment. This condition isolates records that arrived before the corresponding master data was available. Instead of failing the load, BW4 HANA allows these records to persist in an incomplete but usable state. This update statement demonstrates targeted correction. Only affected records are fixed once master data arrives, avoiding full reloads and preserving load performance.
Follow-up 1, mid-level. Should late arriving data ever block a data load?
Answer: no. Blocking loads reduces data availability and creates operational backlog. It is better to allow incomplete context temporarily and correct it later.
Follow-up 2, senior level. How do you prevent reporting confusion caused by incomplete data?
Answer: I use default placeholders, flags, or filters in queries to clearly indicate provisional data until master data is fully available.
Follow-up 3, curveball. Late arriving data keeps growing every day. What does this indicate?
Answer: it usually indicates upstream data quality or sequencing issues. The model is resilient, but the source process must be fixed to prevent permanent inconsistency.
Key takeaway.
BW4 HANA models must tolerate temporal inconsistency. Late arriving data should be corrected surgically, not punished with reloads.
Exclusive pro tip.
Always track the volume of late arriving records. A rising trend is an early warning sign of upstream process failure, not a BW modeling issue.
Scenario 11. Delta handling when source systems don't support delta.
In many real projects, source systems do not provide reliable timestamps or delta indicators. An interviewer asks, if the source sends full data every time with no delta pointer, how do you design a BW4 HANA model that still supports efficient delta loading? This scenario tests whether you can engineer deltas instead of depending on them.
What most candidates say and why it's weak.
Most candidates say, load full data every time and overwrite. Why this is weak: full reloads waste resources, extend load windows, and increase risk. This answer ignores BW4 HANA's ability to create pseudo-deltas using technical tracking and comparison logic.
The interview-winning answer.
When the source has no delta, BW4 HANA can still create one logically. Land incoming data in a write-optimized DSO to capture raw loads quickly. 2. Use a technical load timestamp or request ID as a surrogate delta pointer. 3. Compare incoming records against the active table using business keys. 4. Only propagate new or changed records to downstream standard DSOs. 5. Avoid full overwrites by isolating change detection to a single comparison step. Delta handling is a design responsibility, not a source system dependency. HANA SQL, creating a pseudo-delta from a full data feed. Disclaimer: always test code in a non-production environment. This join compares incoming records with the existing active data using the business key. It forms the foundation of pseudo-delta logic by detecting presence or absence. This condition filters only new records or records whose values have changed. Instead of reloading everything, BW4 HANA propagates only meaningful differences downstream.
Follow-up 1, mid-level. Where should this comparison logic be implemented?
Answer: it should be implemented in the transformation or a MDP layer, feeding the standard a DSO. Centralizing delta logic prevents duplication and keeps downstream models clean.
Follow-up 2, senior level. How do you handle deletes when the source has no delta?
Answer: deletes must be inferred, usually by comparing current keys against historical keys and marking missing records as inactive or deleted through a controlled reconciliation process.
Follow-up 3, curveball. Pseudo-delta works but load time is still high. Why?
Answer: the bottleneck is often the comparison join itself. Large tables without proper partitioning or indexing can make delta detection expensive even if fewer records are propagated.
Key takeaway.
When sources don't provide delta, BW4 HANA still can. Pseudo-deltas trade some compute for massive savings in data movement and load stability.
Exclusive pro tip.
Always partition both staging and active DSOs on the business key or time dimension. Delta detection performance depends more on table design than on SQL logic.
Scenario 12. Why fewer DSOs can outperform a clean layered model.
Many BW architects proudly design 7-8 layered models following textbook LSA++. In interviews, you are asked, why did query performance improve after we removed layers, even though the model became less clean? This tests whether you understand how BW4 HANA actually executes queries.
What most candidates say and why it's weak.
Most candidates say fewer layers mean fewer joins. Why this is weak: while true, it's shallow. It ignores activation cost, data duplication, change log overhead, and how composite providers already provide logical layering without physical duplication.
The interview-winning answer.
In BW4 HANA, excessive layering hurts more than it helps one. Each additional ADSO duplicates data physically, increasing memory footprint. 2. Activation and change log processing multiply with each layer. 3. Composite providers already provide semantic layering without copying data. 4. HANA executes joins faster than BW executes load plus activation cycles. 5. Fewer ADSOs reduce end-to-end latency and simplify recovery during failures. LSA++ is about intent and responsibility, not the number of layers.
Follow-up 1 mid-level. Does this mean LSA++ is obsolete?
Answer: no. LSA++ still defines responsibility boundaries. BW4 HANA simply allows us to implement those boundaries logically instead of physically.
Follow-up 2 senior level. When is heavy layering still justified?
Answer: when data reuse across many consumers is required, or when regulatory traceability demands persisted checkpoints.
Follow-up 3 curveball. Business wants another DSO just to be safe. What do you say?
Answer: I ask what problem that a DSO solves. If it doesn't reduce risk, isolate logic, or improve reuse, it likely adds cost without value.
Key takeaway.
BW4 HANA rewards logical simplicity. Fewer ADSOs often mean faster loads, faster queries, and lower operational risk.
Exclusive pro tip.
If a layer exists only to rename fields or filter records, remove it and push that logic into a composite provider.
Scenario 13. Union versus join inside a composite provider.
Composite providers allow both union and join operations. Interviewers ask, how do you decide between union and join, and what are the performance risks of each? This scenario tests modeling judgment, not syntax.
What most candidates say and why it's weak.
Most candidates say union combines data, join enriches data. Why this is weak: this is correct but incomplete. It ignores cardinality explosion, join selectivity, and how HANA executes joins at scale.
The interview-winning answer.
The decision is driven by data volume and granularity. 1. Use union when combining datasets of the same granularity, for example, actuals plus plan. 2. Use join only when enrichment is unavoidable and cardinality is controlled. 3. Avoid join on high cardinality transactional ADSOs. 4. Prefer joining master data attributes instead of transactional data. 5. Test join selectivity early to avoid runtime explosions. Composite providers are powerful, but misuse turns them into performance traps.
Follow-up 1 mid-level. Why are join riskier than union?
Answer: because join can multiply rows if cardinality assumptions are wrong, while union simply append datasets.
Follow-up 2 senior level. How do you mitigate join risk?
Answer: by validating cardinality, filtering early, and ensuring joins are executed on indexed or low cardinality fields.
Follow-up 3 curveball. Can union ever hurt performance?
Answer: yes. Union all across very large DSOs increases scan volume. It's safer than join but not free.
Key takeaway.
Union is safer. Join is dangerous. Use join only when the business meaning demands it.
Exclusive pro tip.
If you need many join, reconsider whether the model should be virtual at all. Persistence may be cheaper.
Category 2 wrap-up. What you should have realized.
By now, one thing should be clear. BW4 HANA performance problems are rarely caused by missing hardware. They are caused by modeling decisions that look clean on paper but fight how HANA actually executes workloads. Category 2 was about data flow, life cycle, and restraint, knowing when not to add another object.
Please check description or comment section of this video. I have given a lot of links for downloading 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked, system design, most asked implementation project-related questions and answers, support project-related questions and answers. Required for your SAP technical modules interviews jobs like SAP Basis admin jobs, SAP S/4HANA consultant jobs, SAP ABAP developer jobs, SAP BW Data Developer Jobs. SAP Fiori UE5 Developer Jobs. SAP BW HR Consultant Jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people. Also for your interviews, you people can download all 8 PDFs in a single zip file from below given links.
Transition from data flow to virtual power.
So far, we focused on a DSOs, how data is persisted, activated, and moved. Next, we step into the most misunderstood and misused object in BW for HANA, the composite provider. This is where senior interviews are won or lost.
Category 3, Composite Providers and Virtual Modeling.
Theme, flexibility versus control. These scenarios test whether you understand when virtual modeling is a superpower and when it silently destroys performance and stability.
Category 3 Scenarios, 6 scenarios.
1. Why composite providers replaced multi-providers. 2. Union versus join inside a composite provider, when to use which. 3. Performance impact of joins on large DSOs. 4. Handling different granularities in a composite provider. 5. Can composite providers replace transformations? 6. When composite providers become dangerous, these scenarios separate developers who build models from architects who control complexity.
Scenario 13. Why composite providers replaced multi-providers.
In classic BW, multi-providers were the standard way to union multiple InfoCubes or DSOs for reporting. In BW for HANA interviews, a common question is, why did SAP replace multi-providers with composite providers? Was this only a rename, or is there a deeper architectural reason?
What most candidates say, and why it's weak.
Most candidates answer, composite providers are the new version of multi-providers, and they run on HANA. Why this is weak? This answer treats composite providers as a technical upgrade instead of an architectural shift. It ignores push-down logic, HANA execution plans, and the ability to mix persisted and virtual sources in a single semantic layer.
The interview-winning answer.
Composite providers replaced multi-providers because BW for HANA moved responsibility from the BW engine to the HANA Engine 1. Execution pushdown. Multi-providers relied on the BW OLAP processor to union data after retrieval. Composite providers push unions and joins directly into HANA SQL execution. 2. Mixed modeling. Composite providers can combine a DSOs, open ODS views, calculation views, and even external sources in one semantic layer. Multi-providers could not. 3. Join capability. Multi-providers supported only union. Composite providers support both union and join, enabling real-time enrichment without transformations. 4. Single semantic layer. Composite providers eliminate the need for intermediate reporting layers, reducing data duplication and latency. Composite providers are not a replacement object. They are a redesign of where reporting logic executes.
Follow-up 1, mid-level. Does this mean multi-providers are unusable in BW for HANA?
Answer, no. Multi-providers still work in compatibility mode, but they do not benefit from HANA pushdown. SAP recommends composite providers for all new development because they scale better and align with BW for HANA's execution model.
Follow-up 2, senior level. Can composite providers completely replace info providers below them?
Answer, no. Composite providers are virtual by nature. They depend on well-designed DSOs or external sources beneath them. If the underlying data model is weak, a composite provider amplifies the problem instead of fixing it.
Follow-up 3, curveball. When would you deliberately avoid a composite provider?
Answer: I would avoid composite providers when complex joins are required on very large datasets with mismatched granularities. In such cases, a persisted DSO with pre-calculated logic is safer and more predictable for performance.
Key takeaway.
Composite providers exist because BW4 HANA moved reporting intelligence into the HANA database. They reward good modeling decisions and brutally expose bad ones.
Scenario 14, union versus join in a composite provider. When to use which?
You are building a composite provider that combines actuals from finance and forecast data from planning. In the interview, you are asked, should this be a union or a join? What breaks if you choose the wrong one?
What most candidates say and why it's weak.
Most candidates respond, use a union because we want to combine data, or use a join to enrich the data. Why this is weak? These answers are vague and dangerous. Union and join solve completely different problems. Choosing incorrectly can silently duplicate records, explode row counts, or destroy query performance without throwing any error.
The interview-winning answer.
The decision depends entirely on data semantics and grain 1. Use union when datasets represent the same business object at the same granularity, for example, actuals versus plan for the same cost centers. Union stacks records vertically. 2. Use join only when one dataset enriches another at a strictly one-to-one or controlled one-n relationship, for example, joining text attributes or small lookup tables. 3. Never join two large fact-like ADSOs unless cardinality is proven. Otherwise, you create a Cartesian explosion. 4. In planning scenarios, actuals and forecast almost always belong in a union, not a join. Union adds rows. Join multiplies rows. Confusing the two is one of the fastest ways to kill a BW4 HANA system.
Follow-up 1, mid-level. How do you validate cardinality before choosing a join?
Answer: I analyze the ADSO keys and run a count distinct check on join fields. If one side does not guarantee uniqueness, I avoid the join or redesign the model.
Follow-up 2, senior level. What happens if you join actuals and plan with mismatched time granularity?
Answer: the join multiplies records across time buckets, inflating values. Monthly plan joined to daily actuals creates duplicated plan values unless pre-aggregated.
Follow-up 3, curveball. Can a union ever hurt performance?
Answer: yes. If the union to DSOs have very different data volumes or poorly aligned structures, HANA may generate inefficient execution plans. In such cases, harmonizing structures or pre-unioning into a persisted DSO is safer.
Key takeaway.
Union is a modeling decision. Join is an engineering decision. Mixing them without understanding grain is how virtual models collapse at scale.
Scenario 15. Performance impact of joins on large DSOs.
During performance testing, a query on a composite provider suddenly slows down after adding a join between two large DSOs. CPU usage spikes in HANA, but no functional error occurs. In an interview, you are asked, why do joins on large DSOs degrade performance even when the join fields are indexed?
What most candidates say and why it's weak.
Most candidates answer, we need to add better indexes or increase memory. Why this is weak? This assumes the problem is infrastructure. It ignores how HANA executes joins in memory and how row explosion, not missing indexes, is the dominant cost when joining large fact-like tables.
The interview-winning answer.
The slowdown happens because of how HANA processes joins on columnar tables. 1. Join cardinality explosion. Even index joins can multiply intermediate result sets when cardinality is not strictly one-to-one. 2. Late filtering. Filters applied at query time may execute after the join, forcing HANA to process massive intermediate datasets. 3. Memory pressure. Large joins require materializing intermediate columns, increasing memory bandwidth usage. 4. Parallelism limits. As join complexity increases, HANA's ability to parallelize efficiently decreases. Indexes don't fix bad joins. Modeling decisions do.
Follow-up 1, mid-level. How do you detect that a join is the root cause?
Answer: I analyze the HANA execution plan using Plan Viz and look for large intermediate result sets and high join operator costs.
Follow-up 2, senior level. How would you redesign this model to improve performance?
Answer: I would move enrichment logic into a persisted DSO, pre-aggregating or flattening data before reporting. This reduces runtime joins and stabilizes performance.
Follow-up 3, curveball. Why does performance degrade only under peak load?
Answer: under peak load, concurrent queries amplify memory contention and CPU scheduling overhead. Joins that seem acceptable in isolation collapse when executed in parallel.
Key takeaway.
Joins on large DSOs are not free. In BW4 HANA, virtual elegance must be balanced with physical reality.
Scenario 16. Handling different granularities in a composite provider.
You are asked to build a composite provider that combines sales data at daily granularity with target data at monthly granularity. The query technically works, but business users report inflated numbers and inconsistent totals. In the interview, you are asked, why does this happen, and how do you model it correctly?
What most candidates say, and why it's weak.
Most candidates say, we need to align the time characteristics or add filters. Why this is weak: it treats the symptom, not the cause. Simply aligning time characteristics does not resolve semantic granularity mismatches. The issue is not filtering. It is data multiplication caused by incompatible grains.
The interview-winning answer.
The correct approach starts by respecting granularity 1. Granularity awareness: daily sales records will multiply monthly target values when joined or unioned incorrectly. 2. Separate providers: model sales and targets in separate DSOs and expose them via separate composite providers if needed. 3. Controlled alignment: if a single composite provider is required, align data using a calculated key, for example, month, and ensure targets are distributed intentionally, not implicitly. 4. Query design: use restricted or calculated key figures to control how monthly values are interpreted at daily level. Granularity mismatches silently corrupt data. They rarely cause errors, but they always cause wrong answers.
Follow-up 1, mid-level. How can you detect a granularity issue during testing?
Answer: I compare record counts and totals before and after combining datasets. Sudden multiplication of values is a strong indicator of granularity mismatch.
Follow-up 2, senior level. When is it acceptable to distribute monthly targets across days?
Answer: only when the business explicitly defines a distribution rule, such as equal daily spread or working day weighting. Otherwise, distribution introduces assumptions that invalidate reporting.
Follow-up 3, curveball. Why do these issues often escape UAT?
Answer: UAT datasets are usually small and manually validated. Granularity issues surface only at scale, where multiplication effects become visible.
Key takeaway.
Composite providers do not harmonize granularity for you. If you ignore grain, BW4 HANA will happily return mathematically correct but semantically wrong results.
Scenario 17. Can composite providers replace transformations?
A project team decides to remove most BW transformations and push all logic into composite providers using joins, unions, and calculated fields. Initially, development is faster. 6 months later, reporting becomes slow and unpredictable. In an interview, you are asked, why is using composite providers as a replacement for transformations dangerous?
What most candidates say, and why it's weak.
Most candidates say composite providers push logic to HANA, so they are faster and more flexible. Why this is weak: it assumes pushdown is always beneficial. It ignores execution frequency, data reuse, and the difference between runtime logic and load time logic.
The interview-winning answer.
Composite providers are powerful, but they are not a replacement for transformations. 1. Execution timing: transformations run once at load time. Composite provider logic runs on every query execution. 2. Reusability loss: load time logic can be reused across many queries. Runtime logic is re-evaluated repeatedly. 3. Unpredictable performance: as data volume grows, runtime joins and calculations become unstable under concurrent load. 4. Debugging complexity: errors in transformations are caught during load. Errors in CompositeProviders surface only at query time. Pushdown is a performance tool, not a design shortcut.
Follow-up 1, mid-level. What type of logic belongs in a composite provider?
Answer: lightweight joins, unions, and simple calculations that are truly report-specific and do not need persistence.
Follow-up 2, senior level. How do you decide whether logic belongs in a transformation or composite provider?
Answer: I evaluate how often the logic is executed, whether the result can be reused, and how sensitive it is to data volume growth.
Follow-up 3, curveball. Why do teams overuse composite providers despite the risks?
Answer: because they reduce development time and avoid activation delays, even though they shift cost and risk into runtime.
Key takeaway.
Composite providers are for orchestration, not heavy computation. Using them as a replacement for transformations creates invisible technical debt.
Scenario 18. When should you use open ODS views instead of a DSOs?
A business team requests immediate reporting on a new external data source. They want results in days, not weeks. A junior modeler suggests creating an ADSO and loading the data. In the interview, you are asked, when is an open ODS view the correct choice instead of an ADSO?
What most candidates say and why it's weak.
Most candidates say open ODS views are faster because they are virtual. Why this is weak: this focuses only on speed and ignores governance, consistency, and lifecycle management. Virtual does not automatically mean correct or sustainable.
The interview-winning answer.
Open ODS views are the right choice when agility outweighs persistence. 1. Rapid prototyping, when the data model is still evolving and business requirements are unclear. 2. External ownership, when the source system owns data quality and corrections happen outside BW. 3. Low transformation needs, when data requires minimal cleansing or enrichment. 4. Short-term usage, when the reporting need is temporary or exploratory. Open ODS views trade persistence for speed. That trade must be intentional.
Follow-up 1, mid-level. What is the biggest risk of using open ODS views for core reporting?
Answer: performance and consistency. Since data is read at runtime, any source slowness or change directly impacts reporting.
Follow-up 2, senior level. How do you transition from open ODS views to a DSOs?
Answer: once requirements stabilize, I persist the data into a DSOs using the open ODS view as the source, preserving the validated structure.
Follow-up 3, curveball. Why do open ODS views sometimes pass performance tests but fail in production?
Answer: test volumes are small and sources are idle. In production, concurrent access and source-side contention expose runtime weaknesses.
Key takeaway.
Use open ODS views to learn fast, not to run forever. Persistence is what turns prototypes into platforms.
Closing Category 3, flexibility has a cost.
In Category 3, we explored composite providers and virtual modeling. These scenarios showed that flexibility without discipline leads to unpredictable performance and silent data issues. At senior levels, interviewers expect you to know not just what composite providers can do, but when they become dangerous.
Please check description or comment section of this video. I have given a lot of links for downloading 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked, system design, most asked implementation project-related questions and answers, support project-related questions and answers. Required for your SAP technical modules interviews jobs like SAP Basis admin jobs, SAP S4 HANA consultant jobs, SAP ABAP developer jobs, SAP ABAP OData developer jobs, SAP Fiori UE5 developer jobs, SAP ABAP HR consultant jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section. These questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people. Also for your interviews, you people can download all 8 PDFs in a single zip file from below given links.
Up next, Category 4, Open ODS Views and External Data.
Now we move outside classic BW managed data. Category 4 focuses on virtual access, external systems, and why modern BW architects must balance agility with governance when integrating non-SAP and HANA native data.
Category 4, Open ODS Views and External Data.
Theme: modern data integration without breaking BW. These scenarios test whether you understand when virtualization accelerates delivery and when it quietly destroys consistency, performance, and trust.
Scenarios covered in this category.
1. When should you use open ODS views instead of a DSOs? 2. Virtual access versus persisted data, how do you decide? 3. Using open ODS views on HANA tables, risks and benefits. 4. Why not expose raw ECC tables directly to reporting? 5. Handling data consistency with open ODS views. 6. Open ODS views in mixed BW and non-SAP landscapes. These questions reveal whether a candidate understands integration strategy, not just connectivity.
Scenario 19. Using open ODS views on HANA tables, risks and benefits.
A team proposes creating open ODS views directly on native HANA tables to avoid data duplication and speed up delivery. In the interview, you are asked, is this a good idea in BW for HANA? And what are the real risks of modeling open ODS views directly on HANA tables?
What most candidates say and why it's weak.
Most candidates say, yes, this is best practice because it avoids replication and HANA is fast. Why this is weak? It focuses only on performance and ignores governance, semantic stability, transport management, and the fact that BW loses control over data lifecycle and structure.
The interview-winning answer.
Using open ODS views on HANA tables is acceptable only with clear architectural boundaries. 1. Read-only scenarios, suitable when BW is only a consumer and not responsible for data corrections. 2. Stable schemas. The underlying HANA tables must be structurally stable and well-governed. 3. Performance-critical access, when copying large volumes into BW adds unacceptable latency. 4. Clear ownership. Data ownership and change responsibility must sit outside BW. Direct HANA access is a shortcut. Shortcuts must be controlled. SQL. Creating a HANA calculation view used by an open ODS view. Disclaimer. Always test code in a non-production environment. This SQL represents a native HANA view that an open ODS view would consume. BW does not control this logic. Any structural or semantic change here immediately impacts BW reporting without warning or transport checks.
Follow-up 1, mid-level. What happens if a column is added or removed in the HANA table?
Answer: the open ODS view can break at runtime or return inconsistent results. BW has no activation step to catch the change early.
Follow-up 2, senior level. How do you reduce risk when using HANA tables with open ODS views?
Answer: I introduce a stable HANA calculation view as a semantic contract. BW connects only to that view, never directly to base tables.
Follow-up 3, curveball. Why do these models often fail during upgrades?
Answer: because HANA table changes are not synchronized with BW transports. An upgrade can change table definitions without BW awareness.
Key takeaway.
Open ODS views on HANA tables trade BW governance for speed. Without a semantic contract layer, they create fragile reporting architectures.
Scenario 20. Why not expose raw ECC tables directly to reporting?
A developer suggests skipping BW modeling entirely and exposing ECC tables like VBAC, VBAP, or MARA directly to reporting tools through open ODS views. The argument is faster delivery and real-time access. In the interview, you are asked, why is exposing raw ECC tables to reporting a bad architectural decision?
What most candidates say and why it's weak.
Most candidates say ECC tables are complex and not meant for reporting. Why this is weak, while true, it is vague. It does not demonstrate understanding of SAP application semantics, update logic, locking behavior, or how transactional systems behave under analytical load.
The interview-winning answer.
Exposing raw ECC tables to reporting breaks fundamental SAP design principles. 1. Transactional semantics. ECC tables are optimized for frequent updates, not analytical reads. Reporting queries can interfere with business transactions. 2. Complex business logic. Meaningful business values are derived through application logic, not stored directly in tables. 3. Locking and performance risk. Long-running analytical queries can cause table locks or increase response times for users. 4. Upgrade fragility. ECC table structures can change during upgrades, breaking reports without warning. ECC tables are a transactional contract, not a reporting interface.
Follow-up 1, mid-level. How does SAP expect reporting on ECC data to be done?
Answer: through extractors, CDS views, or BW-managed layers that apply business logic, delta handling, and semantic consistency.
Follow-up 2, senior level. Are there any exceptions where direct ECC access is acceptable?
Answer: only for controlled, read-only, low-impact scenarios such as diagnostics or reconciliation, never for enterprise reporting.
Follow-up 3, curveball. Why does direct ECC reporting sometimes work in post-CS but fail in production?
Answer: post-CS run with low concurrency and clean data. In production, transactional load, locking, and volume expose the architectural flaw.
Key takeaway.
Transactional systems are built to run the business, not analyze it. Reporting must respect that boundary to remain stable and scalable.
Scenario 21. Handling data consistency with open ODS views.
A business report built on an open ODS view shows different numbers at different times of the day. The source system data is being updated continuously. In the interview, you are asked, how do you ensure data consistency when using open ODS views?
What most candidates say and why it's weak.
Most candidates say this happens because the data is changing in the source. Why this is weak: it identifies the symptom but offers no architectural control. Interviewers want to hear how you design for consistency, not excuses for inconsistency.
The interview-winning answer.
Data consistency with open ODS views must be designed explicitly. 1. Snapshot logic. Reports must be based on defined cutoff times, not live reads. 2. Source coordination. Align reporting windows with source batch or commit cycles. 3. Virtual filters. Apply time-based or status-based filters to stabilize result sets. 4. Escalation rule. When consistency is critical, persist the data into a DSOs instead of virtual access. Virtual access without consistency rules produces moving targets, not reports.
Follow-up 1, mid-level. Why is consistency harder with open ODS views than a DSOs?
Answer: because a DSOs persist a fixed snapshot of data, while open ODS views read data live at query time.
Follow-up 2, senior level. How do you explain inconsistent numbers to business users?
Answer: I explain that virtual reporting reflects the current state of the source, and propose either defined reporting cutoffs or persistence for stable reporting.
Follow-up 3, curveball. Why do consistency issues often appear only after go live?
Answer: because production systems have continuous updates and concurrency, unlike controlled test environments.
Key takeaway.
Open ODS views provide speed, not certainty. Consistency must be engineered, not assumed.
Scenario 22. Open ODS views in mixed BW and non-SAP landscapes.
An enterprise landscape includes BW for HANA, cloud data sources, and non-SAP databases. The team proposes using open ODS views to virtually connect everything into BW. In the interview, you are asked, how do open ODS views behave in mixed SAP and non-SAP landscapes, and what risks must be managed?
What most candidates say and why it's weak.
Most candidates say Open ODS views make integration easy across systems. Why this is weak? It focuses only on connectivity. It ignores latency, failure domains, data ownership, and the fact that BW becomes dependent on systems it does not control.
The interview-winning answer.
In mixed landscapes, open ODS views must be used selectively. 1. Latency awareness. Non-SAP sources often have higher and less predictable response times. 2. Failure isolation. An outage in a non-SAP system can immediately impact BW reporting. 3. Data ownership clarity. BW should not be accountable for data quality it cannot correct. 4. Hybrid strategy. Use open ODS views for exploration and persist critical data into a DSOs. Virtual integration expands reach, but also expands risk.
Follow-up 1, mid-level. How do you protect BW reporting from non-SAP outages?
Answer: by limiting virtual access to non-critical reports and persisting essential datasets into a DSOs.
Follow-up 2, senior level. How do you explain mixed landscape risks to stakeholders?
Answer: I explain that virtual access couples systems together and propose persistence, where availability SLAs must be met.
Follow-up 3, curveball. Why do mixed landscapes often fail during peak business hours?
Answer: because multiple systems experience load simultaneously, amplifying latency and exposing cross-system dependencies.
Key takeaway.
Open ODS views work best as connectors, not foundations. In mixed landscapes, persistence is what restores architectural control.
Scenario 23. How do you simplify an over-engineered BW model?
You inherit a BW4 HANA system with 5 ADSO layers, multiple transformations doing similar logic, and composite providers stacked on top of each other. Reporting works, but performance is unstable and maintenance is slow. In the interview, you are asked, how would you simplify this BW model without breaking reporting?
What most candidates say and why it's weak.
Most candidates say we should remove unnecessary layers. Why this is weak? It is directionally correct but architecturally shallow. It does not explain how to decide which layers add value and which ones only add latency and complexity.
The interview-winning answer.
A BW architect simplifies by following data value, not tradition 1. Usage analysis first. Identify which DSOs and composite providers are actually used by queries. 2. Logic consolidation. Move duplicated transformation logic into a single, well-defined layer. 3. Remove pass-through layers. Eliminate DSOs that only forward data without enrichment or validation. 4. Persist where it stabilizes. Persist complex joins or calculations that are reused across reports. Simplification is not deletion. It is intentional consolidation.
Follow-up 1, mid-level. How do you ensure simplification does not break reports?
Answer: by running usage statistics and validating results query by query, while removing or merging layers incrementally.
Follow-up 2, senior level. Why do over-engineered models usually come from good intentions?
Answer: because teams optimize for flexibility and future-proofing, but underestimate the long-term cost of runtime complexity.
Follow-up 3, curveball. Why does simplification often improve performance immediately?
Answer: because fewer layers reduce data movement, joins, and execution paths, lowering CPU and memory pressure.
Key takeaway.
BW4 HANA performance improves fastest when architecture becomes simpler, not when hardware becomes bigger.
Scenario 24. When is push-down logic to HANA a bad idea?
A migration project aggressively converts ABAP transformations into HANA SQL script and AMP. Initially, performance improves. Months later, loads slow down and debugging becomes nearly impossible. In the interview, you are asked, when does pushing logic down to HANA actually make things worse?
What most candidates say and why it's weak.
Most candidates say pushdown is bad when SQL script is complex. Why this is weak? Complexity alone is not the problem. The real issue is control flow logic that performs well in ABAP but explodes in cost when translated into set-based execution.
The interview-winning answer.
Pushdown logic fails when the algorithm is procedural, not relational one. Nested loops, ABAP loops that depend on row-by-row state translate poorly into SQL. 2. Conditional branching, complex IF logic becomes expensive case expressions. 3. High cardinality lookups, repeated lookups inside loops explode into massive joins. 4. Debugging cost, SQL script errors surface only at runtime and are harder to trace. HANA is fast at sets, not at pretending to be a BAP. A BAP logic procedural loop that performs well at load time. Disclaimer, always test code in a non-production environment. This ABAP loop executes efficiently because it operates in memory with controlled iteration. The lookup table is buffered, and the logic is applied row by row during data load. SQL script pushdown, equivalent logic that scales poorly. Disclaimer, always test code in a non-production environment. This SQL script version forces HANA to execute a large join across full datasets. What was a cheap in-memory lookup in a BAP becomes an expensive relational operation at scale.
Follow-up 1, mid-level. How do you decide whether logic should stay in a BAP?
Answer: if the logic depends on sequential processing, lookups, or conditional branching, it usually belongs in a BAP transformations.
Follow-up 2, senior level. How do you explain this trade-off to stakeholders?
Answer: I explain that pushdown optimizes execution engines, not algorithms. The wrong algorithm will be slow everywhere.
Follow-up 3, curveball. Why do teams still push everything down to HANA?
Answer: because initial benchmarks look good on small datasets, hiding the long-term cost of scale and maintainability.
Key takeaway.
Pushdown is a scalpel, not a hammer. Use it to optimize sets, not to rewrite procedural logic.
Category 4 complete. What you should internalize.
Open ODS views are not a shortcut. They are a deliberate architectural choice. This category tested whether you understand virtual access, data consistency, and why BW must still protect reporting layers from raw source volatility. Senior architects use OpenODS views to extend BW, not to weaken it.
Please check description or comment section of this video. I have given a lot of links for downloading 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked, system design, most asked implementation project-related questions and answers, support project-related questions and answers. Required for your SAP technical modules interviews jobs like SAP Basis admin jobs, SAP S4 HANA consultant jobs, SAP ABAP developer jobs, SAP ABAP OData developer jobs, SAP Fiori UE5 developer jobs, SAP ABAP HR consultant jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people. Also for your interviews, you people can download all 8 PDFs in a single zip file from below given links.
Transition from modeling objects to architectural judgment.
So far, we focused on choosing the right BW objects. Now we move to something harder, making trade-offs. This next category tests whether you can balance performance, flexibility, maintainability, and future scale. The real job of a BW4 HANA architect.
Category 5. Modeling trade-offs and architecture judgment.
Theme: thinking like a BW architect. These scenarios separate engineers who can build models from architects who can sustain them. There are no perfect answers here, only justified decisions based on system behavior, scale, and long-term cost.
Category 5. Scenarios architecture judgment.
1. How do you simplify an over-engineered BW model? 2. When is push-down logic to HANA a bad idea? 3. Handling historical data versus current reporting efficiently. 4. Balancing flexibility versus performance in enterprise BW models. 5. Why some BW models fail during scale, not design. 6. How you would redesign a classic BW system into BW for HANA. Interviewers expect you to explain trade-offs, not chase best practices blindly.
Scenario 25. How do you simplify an over-engineered BW model?
You inherit a BW for HANA system built over many years. It has multiple ADSO layers, several composite providers chained together, redundant transformations, and complex process chains. Reporting is slow, changes are risky, and no one fully understands the data flow. The interviewer asks, how would you simplify this BW model without breaking the business?
What most candidates say and why it's weak.
Most candidates say we should remove unnecessary objects or redesign everything. Why this is weak? It sounds destructive and risky. It shows no structured approach, no understanding of dependency management, and no respect for business continuity. Interviewers look for controlled simplification, not reckless cleanup.
The interview-winning answer.
I simplify BW models incrementally, starting from usage and value, not structure one. Start with consumption. Identify which queries, composite providers, and DSOs are actually used by the business. 2. Collapse redundant layers. Remove DSOs that only pass data through without adding business logic or delta value. 3. Move logic to the right place. Push simple joins and calculations into composite providers, but keep heavy cleansing in DSOs. 4. Reduce chain depth. Replace multi-hop data flows with fewer purpose-driven objects. 5. Protect business continuity. Use parallel models and composite provider unions to switch consumers gradually. Simplification is about reducing risk and complexity, not deleting objects blindly.
Follow-up 1. Mid-level. How do you identify DSOs that can be removed safely?
Answer: if an DSO has no reporting consumption, no delta dependency, and no unique business logic, it is usually a candidate for removal or merging.
Follow-up 2. Senior level. What is the biggest risk when simplifying BW models?
Answer: breaking hidden dependencies, especially in process chains, authorizations, or legacy queries that are still used indirectly by business users.
Follow-up 3. Curveball. Business wants faster performance but refuses any structural changes. What do you do?
Answer: I prove the impact using query runtimes and execution plans. Then propose a parallel simplified model that delivers measurable improvement without touching the existing one.
Key takeaway.
Over-engineered BW systems fail not because they are complex, but because their complexity no longer adds business value.
Exclusive pro tip.
If you cannot explain the end-to-end data flow on one whiteboard, the model is already too complex.
Scenario 26. When is push-down logic to HANA a bad idea?
During a BW for HANA migration, a team aggressively converts ABAP transformations into HANA SQL script and AMP to maximize pushdown. Initial tests look promising, but in production the loads slow down and debugging becomes extremely difficult. The interviewer asks, when does pushing logic down to HANA actually become the wrong decision?
What most candidates say and why it's weak.
Most candidates say pushdown is bad when SQL script is complex. Why this is weak? Complexity alone is not the problem. The real issue is algorithm suitability. Some logic is inherently procedural and performs better in ABAP than in set-based SQL execution.
The interview-winning answer.
Pushdown logic fails when the business algorithm does not map cleanly to set-based processing. 1. Procedural loops, row-by-row logic with stateful dependencies performs poorly when converted into joins. 2. Conditional branching, nested if or else logic becomes expensive case expressions in SQL. 3. High cardinality lookups, repeated lookups inside loops explode into massive joins at scale. 4. Operational risk. SQL script errors surface only at runtime and are harder to debug than ABAP. HANA accelerates data movement, not poor algorithms. ABAP transformation logic, procedural enrichment that executes efficiently. Disclaimer: always test code in a non-production environment. This ABAP loop performs well because it uses buffered internal tables and controlled iteration during the load process. The algorithm is procedural by nature and fits a BAP execution. SQL script pushdown, set-based rewrite that degrades at scale. Disclaimer: always test code in a non-production environment. This SQL script forces HANA to evaluate a full join across large datasets. What was a cheap lookup in a BAP becomes an expensive relational operation when data volume grows.
Follow-up 1, mid-level. How do you decide whether logic should remain in a BAP?
Answer: if the logic depends on sequential processing, stateful decisions, or repeated lookups, it usually belongs in a BAP rather than SQL script.
Follow-up 2, senior level. How do you explain this trade-off to stakeholders pushing for full pushdown?
Answer: I explain that pushdown optimizes execution engines, not business algorithms. The wrong algorithm will be slow regardless of where it runs.
Follow-up 3, curveball. Why does pushdown often look good during testing but fail later?
Answer: because test datasets are small. Scale exposes join explosion and execution plan inefficiencies that were invisible during post-CS.
Key takeaway.
Pushdown is powerful only when the logic is naturally relational. Forcing procedural logic into SQL script creates long-term performance and maintenance debt.
Scenario 27. Handling historical data versus current reporting efficiently.
Your BW4 HANA system contains 10+ years of transactional history. Business users frequently run reports for the last 30 days, while auditors occasionally request full historical analysis. Performance is degrading, memory usage is high, and system costs are increasing. The interviewer asks, how would you redesign the model to handle both current and historical reporting efficiently?
What most candidates say and why it's weak.
Most candidates say, we should archive old data or add more memory. Why this is weak: archiving alone does not solve reporting performance, and scaling memory blindly increases cost without addressing access patterns. This answer shows no understanding of data temperature, query behavior, or how BW4 HANA is designed to separate hot and cold workloads.
The interview-winning answer.
I would redesign the model using a multi-temperature data strategy. 1. Separate hot versus cold data. Keep recent, frequently accessed data, for example, last 30-90 days, in a primary DSO optimized for reporting. 2. Leverage data tiering optimization DTO, move older, infrequently accessed historical data to warm or cold tiers while keeping it logically accessible. 3. Unified consumption layer. Use a composite provider to union hot and cold data transparently so business users see one logical dataset. 4. Query optimization. Apply filters and variables to ensure most queries hit the hot tier by default, minimizing access to cold storage. 5. Cost control. This design reduces memory pressure while preserving full auditability and historical insight. This aligns performance, cost, and business expectations without sacrificing data availability.
Follow-up 1, mid-level. Why not just keep everything in one DSO and rely on HANA performance?
Answer: because HANA performance is not free. Large volumes increase memory footprint, affect cache efficiency, and slow down even simple queries. Separating data by access frequency ensures predictable performance and lower TCO.
Follow-up 2, senior level. How do you ensure users don't accidentally run heavy queries on cold data?
Answer: by using default query filters, restricted key figures, and variables that limit date ranges. Additionally, authorizations or query views can be designed so historical access is intentional, not accidental.
Follow-up 3, curveball. What if auditors require frequent access to 5+ years of data?
Answer: then the definition of cold changes. I would move that data to a warm tier instead of cold, or create a dedicated audit reporting a DSO optimized for long-range queries, isolating that workload from operational reporting.
Key takeaway.
BW4 HANA performance problems are often caused by mixing hot and cold workloads. Architects design for access patterns, not just data volume.
Exclusive pro tip.
Always ask the business how often historical data is accessed. Most systems fail because architects assume rarely used means never used. Designing for reality prevents future rework.
Scenario 28. Balancing flexibility versus performance in enterprise BW models.
Your BW4 HANA system supports multiple business units with changing reporting requirements. Over time, The model has become highly flexible with many joins, optional characteristics, and generic composite providers. However, query performance is inconsistent and tuning efforts keep increasing. The interviewer asks, how do you balance flexibility and performance in enterprise BW models?
What most candidates say and why it's weak.
Most candidates say we should optimize queries or add more indexes. Why this is weak: index tuning treats the symptom, not the cause. The real issue is architectural overflexibility. This answer shows no understanding of how modeling choices directly affect join complexity, execution plans, and system predictability.
The interview-winning answer.
I treat flexibility and performance as competing forces and design intentional boundaries. 1. Separate core versus optional reporting. Core KPIs and dimensions go into a lean, high-performance composite provider with minimal joins. 2. Use extension models. Additional flexibility is provided through separate composite providers or query views layered on top, not baked into the core model. 3. Avoid over-generic designs. One model that tries to serve all use cases usually serves null well. Purpose-built models perform better. 4. Limit join explosion. I control the number of joined DSOs and avoid chaining joins across multiple layers. 5. Govern change requests. Flexibility is added only when there is a clear business case, not as a default design choice. Good BW architects design flexibility consciously, not accidentally.
Follow-up 1, mid-level. How do you identify when a model has become too flexible?
Answer: when small reporting changes require touching multiple objects, query runtimes vary wildly, or developers are afraid to change the model. Flexibility has crossed into fragility.
Follow-up 2, senior level. Business demands flexibility. How do you say no without blocking them?
Answer: I don't say no, I redirect. I offer extension layers or sandbox models where flexibility is allowed, while keeping the core reporting layer stable and optimized.
Follow-up 3, curveball. Can too much performance optimization also be a problem?
Answer: yes. Over-optimized models become rigid and expensive to change. The goal is not maximum performance, but predictable performance with controlled evolution.
Key takeaway.
Flexibility is not free. In BW4 HANA, every extra join and option has a performance cost that compounds over time.
Exclusive pro tip.
If a composite provider needs more than 6-8 joins to answer its primary business question, it's usually a sign the model needs to be split.
Scenario 29. Why some BW models fail during scale, not design.
A BW4 HANA model performs perfectly in development and QA. Queries are fast, loads complete on time, and business users are satisfied. After go live, data volume grows 20 times, concurrency increases, and suddenly queries slow down dramatically. The interviewer asks, why do BW models often fail at scale even when the design looked correct?
What most candidates say and why it's weak.
Most candidates say the data volume increased, so performance degraded. Why this is weak: every system grows in volume. This answer fails to explain which architectural decisions break under scale, especially joins, cardinality, partitioning, and concurrency amplification.
The interview-winning answer.
BW models fail at scale because certain design decisions amplify cost non-linearly. 1. Join explosion. Composite providers that join multiple large DSOs multiply data scans under concurrency. 2. Missing partitioning. Tables designed without time or hash partitioning degrade as they grow. 3. High cardinality characteristics, free text or document-level fields cause massive memory pressure. 4. Concurrency blindness. Designs validated with one user fail when 50 users execute the same query. 5. Hidden runtime logic. Formula-heavy queries shift load from HANA engine to OLP processor. Good design works at small scale. Great design survives concurrency and growth. HANA SQL. Unpartitioned DSO causing full table scans at scale. Disclaimer: always test code in a non-production environment. Without partitioning on CalYear or Comonth, HANA must scan the entire ADSO active table. As data grows, response time increases linearly for every user. HANA SQL, correcting the design with semantic partitioning. Disclaimer: always test code in a non-production environment. By partitioning on CalYear, HANA prunes irrelevant partitions at runtime. Queries now scan only the active year, stabilizing performance even as historical data grows.
Follow-up 1, mid-level. Why didn't this issue appear in QA?
Answer: QA datasets are small and concurrency is low. Scale-related failures only surface when data volume and parallel execution increase together.
Follow-up 2, senior level. How do you test scale before production?
Answer: I simulate concurrency, validate partition pruning, analyze execution plans, and test with production-sized data slices, not full copies.
Follow-up 3, curveball. Can over-partitioning also cause problems?
Answer: yes. Too many small partitions increase metadata overhead and planning time. Partitioning must balance pruning efficiency and management cost.
Key takeaway.
BW models don't fail because of bad ideas. They fail because small design shortcuts become expensive under volume and concurrency.
Scenario 30. How would you redesign a classic BW system into BW for HANA?
You inherit a classic BW 7.x system with InfoCubes, multi-providers, heavy transformation layers, and long data load windows. The business wants to migrate to BW for HANA, but insists on minimal downtime and no regression in reporting. The interviewer asks, how would you redesign this system for BW for HANA?
What most candidates say and why it's weak.
Most candidates say, convert InfoCubes to a DSOs and multi-providers to CompositeProviders. Why this is weak? This is a technical conversion answer, not an architectural redesign. It ignores data flow simplification, push-down opportunities, reporting strategy, and long-term scalability.
The interview-winning answer.
I would redesign the system in phases, focusing on simplification and business continuity. 1. Stabilize first. Use shell conversion to keep existing reporting alive while introducing BW for HANA objects in parallel. 2. Collapse layers. Reduce unnecessary PSA to DSO to cube chains into a lean LSA++ model with fewer ADSOs. 3. Replace multi-providers. Introduce composite providers only where virtual modeling adds flexibility, not everywhere. 4. Push logic selectively, move simple aggregations to HANA, but keep complex business rules in BW transformations. 5. Reposition reporting, shift reporting to composite providers or reporting-enabled DSOs based on query patterns. 6. Plan for the future, design models assuming SAC and external consumption, not just BEX queries. The goal is not to convert objects, it is to convert thinking.
Follow-up 1, mid-level. Would you migrate everything at once or incrementally?
Answer: incrementally. I would prioritize high-impact, high-pain areas first, such as long-running loads or slow queries, while keeping stable areas untouched until later phases.
Follow-up 2, senior level. How do you avoid breaking reports during redesign?
Answer: by using composite providers as abstraction layers. They allow me to swap underlying data models without changing the reporting interface.
Follow-up 3, curveball. When would you intentionally keep a classic design element?
Answer: if a process is stable, low volume, and business critical, redesigning it may add risk without real benefit. BW for HANA modernization should be pragmatic, not dogmatic.
Key takeaway.
A successful BW for HANA redesign is not a migration project. It is an architectural refactoring guided by performance, simplicity, and future consumption needs.
Part 1 complete. Thinking like a BW for HANA architect.
In Part 1, we focused on the brain of BW for HANA, modeling decisions, object selection, and architectural trade-offs. These scenarios test whether you understand why BW for HANA was built the way it is, and whether you can design systems that scale, simplify, and survive real production pressure.
Why Part 1 matters in interviews.
Senior interviewers expect more than syntax knowledge. They look for candidates who can explain why an ADSO exists when virtual modeling becomes dangerous, and how poor design choices silently fail at scale. If you can reason through these scenarios, you are already operating at architect level.
Please check description or comment section of this video. I have given a lot of links for downloading 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem solving, generally most asked, system design. Most asked implementation project-related questions and answers. Support project-related questions and answers. Required for your SAP technical modules interviews jobs like SAP Basis admin jobs, SAP S4 HANA consultant jobs, SAP ABAP developer jobs, SAP ABAP OData developer jobs, SAP Fiori UE5 developer jobs, SAP ABAP HR consultant jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people. Also for your interviews, you people can download all 8 PDFs in a single zip file from below given links.
Now we move to part 2, the veins, data provisioning and extraction.
Even the best BW4 HANA model fails if data arrives late, duplicated, inconsistent, or untraceable. In part 2, we shift from modeling theory to data movement reality, how data actually flows into BW4 HANA from SAP and non-SAP sources.
What part 2 tests in interviews?
These scenarios test whether you understand extraction frameworks, delta mechanics, real-time streaming, and error handling. Interviewers use these questions to identify candidates who have operated BW systems in production, not just modeled them on paper.
Part 2, the veins, complex data provisioning.
Even the most advanced data model is useless without a high-velocity data supply. In part 2, we move from the brain to the veins. We are dissecting the operational data provisioning ODP framework, real-time streaming architectures, and the shift from traditional SAP extractors to CDS-based extraction. This section tests your ability to feed the warehouse at the speed of business.
Part 2, data provisioning scenarios we will cover.
31. ODP framework CDS views versus classic extractors. 32. Real-time streaming process chains versus RDA. 33. SLT replication for SAP and non-SAP sources. 34. Handling unstructured and changing flat files. 35. Delta logic when the source has no delta. 36. S4 HANA logistics extraction without setup tables. 37. SDA versus SDI. Virtual access versus replication. 38. Connecting BW4 HANA to SAP Datasphere. 39. DTP error stack and load failure recovery. 40. Migrating legacy 3.x data sources to ODP. This is where BW4 HANA theory meets operational reality.
Scenario 31, ODP framework, CDS views versus classic extractors.
You are migrating a legacy BW landscape to BW4 HANA. The source system is S4 HANA. For financial accounting data, a CDOCA, you need to decide whether to use the classic SAP extractors, ODP-SAPI, or build custom ODP-CDS views. How do you justify the choice to the enterprise architect?
What most candidates say and why it's weak.
Many candidates say, use classic extractors because they are proven and support delta logic. Or they say always use CDS because it is the new standard. Why this is weak? It ignores the embedded analytics strategy. Classic extractors often require complex setup table runs, downtime, whereas ODP-CDS allows direct access to the application tables without intermediate storage, reducing data footprint and latency.
The interview-winning answer.
I would prioritize ODP-CDS for S4 HANA extraction for 3 strategic reasons. 1. Unified architecture. CDS is the strategic modeling layer for S4 HANA. Using ODP-CDS allows us to reuse the same logic for both embedded analytics and BW4HANA extraction. 2. Delta simplicity. ODP-CDS leverages the change data capture, CDC annotations. This eliminates the need for legacy delta queues, RSA7, and moves extraction logic to the database layer, HANA. 3. Performance. CDS views push the join and filter logic down to the database, resulting in faster extraction packages compared to the ABAP-heavy classic extractor logic. However, I would stick to classic extractors for complex logistics modules, where the SAP standard ODP-SAP already handles 100+ table joins that are too risky to rebuild in CDS. Data Definition Language, DDL. CDS view with CDC annotations for ODP extraction. Disclaimer: always test code in a non-production environment. This specific annotation is what registers the CDS view into the ODP framework. Without this, the view is just a standard DDL and cannot be seen by the BW4HANA ODP-CDS source system. This is the magic for delta handling. We tell ODP to use the CPU date field as the delta pointer. This creates a virtual delta queue that BW4HANA can consume automatically without using the old RSA7 transaction.
Follow-up 1. If we use ODP-CDS, where is the data stored before BW picks it up? Does it increase S/4HANA database size?
Answer: ODP-CDS does not physically store the data in a queue like the old PSA. It uses the operational delta queue, ODQ, which is a pointer-based system. It stores the data in a compressed format in the source system only until all subscribers, like BW, have fetched it, so the impact on DB size is minimal and temporary.
Follow-up 2. You have built a custom ODP-CDS view, but the delta is missing records that were deleted in S/4HANA. Why?
Answer: standard delta by element only tracks new or changed timestamps. It cannot see physical deletions. To handle deletions in ODP-CDS, we must use the CDC, change data capture, mapping approach, which leverages the database trigger logs via the analytics.data-extraction.delta.change data capture annotation.
Follow-up 3. Curveball. We have two BW systems, production and test, extracting from the same S/4HANA ODP source. Will they interfere with each other's deltas?
Answer: no. The ODP framework uses subscribers. Each BW system registers as a unique subscriber with a unique subscription ID in the ODQ. S/4HANA maintains separate delta pointers for each, so one system can be 3 days behind without affecting the other's real-time delta.
Key takeaway.
ODP is the center of the BW4HANA universe. Moving to ODP-CDS is not just a trend. It is the only way to align your warehouse with the S/4HANA Clean Core strategy.
Exclusive pro tip, the ODQ-MON secret.
In your interview, mention the ODQ-MON transaction. Every senior consultant knows RSA7, but an architect knows that in BW4HANA, ODQ-MON is the single most important tool for monitoring data health, managing delta subscriptions, and troubleshooting extraction throughput.
Scenario 32, real-time architecture streaming process chains versus RDA.
A high-frequency trading client requires dashboard updates every 60 seconds. They are currently using real-time data acquisition, RDA, in BW 7.5. You are designing their new BW4HANA environment. How do you migrate this near real-time requirement?
What most candidates say and why it's weak.
Candidates often say, we will just create the same RDA objects in BW4HANA. Why this is weak? RDA, real-time data acquisition, is officially deprecated and unsupported in BW4HANA. It relied on info packages and daemon jobs that do not exist in the new architecture. If you suggest RDA, you prove you have not read the simplification list.
The interview-winning answer.
I would replace the legacy RDA with streaming process chains. This modern approach uses a push model instead of a pull model one. ODP push, the source system, via ODP, sends a notification that new data is available. This immediately triggers the process chain. 2. Streaming mode. The process chain is configured in streaming mode. It does not wait for a schedule. It remains active and executes the DTP as soon as a request is received. 3. Immediate activation. The target DSO must be configured for real-time ingestion, allowing it to handle frequent small loads without the overhead of massive activation cycles. SQL. Monitoring high-frequency streaming load requests in the ADSO inbound queue. Disclaimer: always test code in a non-production environment. In a streaming scenario, data lands first in the inbound queue table, the AQ table. Monitoring this table directly via SQL allows the architect to see if the streaming process chain is keeping up with the source frequency. Frequent small loads can lead to a request explosion. We look for pending activations to determine if we need to adjust the streaming threshold to group more requests together for better performance.
Follow-up 1. If we have 100 loads per hour via streaming, will not the DSO activation become a bottleneck?
Answer: yes, if not managed. We must use the streaming property in the process chain to allow multiple requests to be combined into a single activation. This balances the need for real-time reporting with the technical requirement of HANA table compression.
Follow-up 2. Can we use streaming for all data sources in BW for HANA?
Answer: no. Only ODP-based source systems like S/4HANA, SLT, or SAP BW natively support the streaming trigger. For non-ODP sources like flat files, we would still use a traditional scheduled process chain with a high frequency, for example, every 5 minutes.
Follow-up 3. Curveball. The client wants real-time data, but the ADSO has a complex start routine. How does this affect streaming?
Answer: streaming is data-driven, meaning it fires for every tiny packet. If your transformation has a heavy ABAP start routine, for example, thousands of lookups, the overhead of calling that routine 100 times an hour will kill performance. In this case, I would move the lookup logic into a HANA view or a MDP to take advantage of the HANA execution flag in the DTP.
Key takeaway.
RDA is a legacy pull concept. Streaming process chains are a modern push reality. The shift reduces CPU idle time and ensures data is ready for reporting seconds after it is created.
Exclusive pro tip. The request limit strategy.
When designing streaming for massive volume, set the maximum number of requests in a DSO before activation to a value like 50. This forces the system to group small streaming packets into meaningful batches, preventing the HANA database from having thousands of small, uncompressed delta fragments.
Scenario 33. SLT integration, trigger-based replication for non-SAP sources.
A client has a high-volume legacy Oracle database for manufacturing logs. They need these logs in BW for HANA for real-time quality analysis. The source database does not have a reliable changed at timestamp for delta extraction. How do you architect a replication strategy that ensures zero data loss without a full reload?
What most candidates say and why it's weak.
Most candidates suggest using Smart Data Access, SDA, to virtually connect to Oracle or a standard SQL extractor. Why this fails? Virtual access via SDA creates a massive performance hit on the source Oracle DB during heavy reporting. Using a standard SQL extractor is impossible here because the source lacks a delta pointer, timestamp, meaning you would be forced to do full reloads of millions of records every time.
The interview-winning answer.
I would implement SAP Landscape Transformation, SLT, combined with the ODP-SLT Framework 1. Trigger-based capture. SLT installs a DB-level trigger on the Oracle source. Any insert, update, or delete is immediately captured in a logging table regardless of whether the record has a timestamp. 2. ODP integration. I would connect the SLT server to BW for HANA using the ODP-SLT context. This allows BW to treat the SLT stream as a standard Delta-enabled data source. 3. Real-time propagation. I would use a streaming process chain to push these SLT triggers directly into a write-optimized DSO, ensuring the manufacturing logs are available for analysis within seconds of being created in Oracle. Here is SQL code showing how to monitor the SLT logging table for pending record changes. Disclaimer: always test code in a non-production environment. Here is the code showing the operation code. Unlike standard extractors that struggle with deletions, This code snippet proves how SLT captures the specific decode for deletes directly from the database trigger, ensuring the warehouse stays perfectly synchronized with the source. In this code block, we filter for unprocessed records. This demonstrates how the SLT framework maintains its own delta pointer. Only records marked as N will be picked up by the next ODP fetch, preventing duplicate data loads into BW4 HANA.
Follow-up 1. What happens if the SLT server goes down? Do we lose the data changes that happened during the outage?
Answer: no data is lost. The database triggers on the Oracle source remain active and continue to populate the logging table. Once the SLT server is restored, it simply picks up from the last process sequence number and catches up. The only limit is the disk space available on the source for the logging table.
Follow-up 2. The source Oracle table has 1 billion records. How do you handle the initial load without crashing the production database?
Answer: I would use parallel processing and reading types in SLT. By setting the reading type to 4 or 5, we can use multiple background jobs to read the table in chunks. I would also schedule the initial load during off-peak hours and use a DB hint to ensure the Oracle optimizer uses a primary key index for the scan.
Follow-up 3. Curveball. Can you perform data transformations, like masking a credit card number, inside the SLT server before it hits BW4 HANA?
Answer: yes, using event rules in the LTRS transaction. We can write ABAP code snippets within SLT to transform, filter, or mask data during the replication process. This is a best practice for security, as it ensures sensitive data never even leaves the source network unmasked.
Key takeaway.
SLT is the bridge between the old world of full loads and the new world of continuous streams. It is the most robust way to handle non-SAP data that lacks standard delta logic.
Exclusive pro tip. The SLT latency monitor.
If you are in a technical panel, mention that you monitor table latency in transaction LTRM. If the latency between source DB and logging table is 0, but the latency to target is high, the bottleneck is your network or the BW4 HANA inbound processing, not the source database.
Scenario 34. Flat file automation, handling unstructured and shifting CSVs.
A logistics partner uploads a CSV file to an AL11 directory daily. However, they frequently change the order of columns or add new optional columns without notifying you. Your standard info package style load keeps failing. How do you build a resilient ingestion process?
What most candidates say and why it's weak.
Many candidates say, tell the partner not to change the format or build a custom ABAP program to parse the file and map it to info objects. Why this is weak: you cannot control external partners, and hard-coding column indexes in ABAP is the definition of brittle design. It requires constant code changes every time the file structure shifts, which is not scalable in a modern enterprise.
The interview-winning answer.
I would use a field-based modeling approach combined with a header-aware mapping logic. 1. Inbound layer, I create a right-optimized DSO using only fields, not info objects, that match the maximum possible columns the partner might send. 2. Header-based DTP, in the transformation, I do not map by position. I write a start routine that reads the first row of the CSV, the header names, and dynamically maps values to the ADSO fields by name. 3. Schema resilience. If a new column is added, the load will not fail. The new column is simply ignored until I decide to add it to the ADSO. If columns are reordered, the name-based mapping ensures the data still lands in the right field. Here is Python code showing how to handle dynamic CSV column mapping for an inbound data load. Disclaimer: always test code in a non-production environment. Here is the code showing the core mapping logic. Instead of failing when it sees an unknown column, this code snippet uses a list comprehension to intelligently filter the data. It only extracts the columns our DSO expects, effectively ignoring any noise or experimental columns the partner might have added. In this code block, we read the file using its internal headers. This proves our architecture is position independent. Whether shipment_ID is the first column or the 10th, the logic will find it by name, making the ingestion process truly resilient to change.
Follow-up 1. If we use field-based modeling, when do we convert these raw fields into standard SAP info objects?
Answer: the conversion happens at the propagation layer. We keep the inbound layer raw and flexible fields. In the transformation moving to the next DSO, standard DSO, we map these fields to info objects. This allows us to maintain data lineage while ensuring our system of entry is never a bottleneck for format changes.
Follow-up 2. What if the partner sends a file where a mandatory column, like date, is missing entirely?
Answer: I would implement a data quality check in the start routine. If the required header is not found in the first row, the script should raise a technical error and move the file to an error folder. We should never load incomplete records that break downstream business logic.
Follow-up 3. Curveball. The partners are now sending 1,000 small files a day instead of one big one. How does this change your design?
Answer: this is a shift to event-driven ingestion. I would use the file watcher capability in the SAP BW process chain or an external tool like SAP Data Intelligence. As soon as a file lands, it triggers a streaming process chain. Loading 1,000 files via standard batch jobs would create too much overhead.
Key takeaway.
Do not build brittle integrations. By using field-based DSOs and header-aware mapping, you create a warehouse that can survive the chaos of external data partners without constant maintenance.
Exclusive pro tip, the field name hack.
When creating a field-based DSO for CSVs, use the exact technical header name from the CSV as your field name. This makes your transformation logic 100% transparent and allows for auto-mapping in the transformation editor, saving you hours of manual dragging and dropping.
Scenario 35. Handling deltas, pseudo-delta logic when source has no timestamps.
A legacy mainframe system provides a daily full dump of active contracts. It contains 5 million records, but only about 2,000 change daily. The source system has no last updated timestamp and no change flags. How do you architect a solution to identify only the changes, deltas, without overloading the warehouse with 5 million redundant records every day?
What most candidates say and why it's weak.
Most candidates suggest doing a full load every day into a standard DSO with overwrite logic. Why this fails? While the final data might be correct, you are wasting massive amounts of CPU, network, and I or O bandwidth moving 5 million records to process 2,000 changes. This approach does not scale as the volume grows and makes it impossible to track change history because every record is technically updated every day.
The interview-winning answer.
I would implement a pseudo-delta pattern using a 3-layer comparison strategy. 1. Staging layer. Load the full dump into a write-optimized DSO staging where we keep only the latest request. 2. Delta detection. In the transformation to the next layer, I write an MDP SQL script that compares the new data with the current active data using a hash comparison on all non-key fields. 3. Selective update. Only records where the hash has changed or where the key is new are passed to the propagation layer, standard DSO. This reduces the downstream processing from 5 million records to just the 2,000 real changes. Here is SQL code showing how to identify new or changed records from a full dump using a pseudo-delta pattern. Disclaimer: always test code in a non-production environment. Here is the code snippet showing how we detect brand new entries. By using a left outer join, this code block identifies records that exist in today's dump but are missing from our warehouse, allowing us to insert them immediately as part of the delta. In this code block, we use a high-performance hash comparison. Instead of checking 50 different columns one by one, this code snippet generates a single fingerprint for the entire record. If the fingerprints do not match, we know the data has changed, effectively creating a pseudo-delta from a static file.
Follow-up 1. If the source only sends active records, how do you detect if a contract was deleted in the mainframe?
Answer: we use reverse delta detection. After the main load, we look for records that exist in our active DSO but were not present in today's full dump. We can then trigger a 0 record or a cancellation request to mark those contracts as closed in BW for HANA.
Follow-up 2. Performing a join on 5 million records every day is expensive. How do you optimize this performance in HANA?
Answer: I would ensure that both the staging and active tables are partitioned by the same key, for example, contract ID, and reside on the same HANA node. This enables partition-wise joining, where the database only compares matching chunks of data, drastically reducing memory consumption and execution time.
Follow-up 3, Curveball. Can we use internal BW delta settings to handle this without custom SQL logic?
Answer: no. Standard BW delta settings, like generic delta, require a numeric or date-based pointer provided by the source. Since our source system provides neither, the internal delta has nothing to track. The custom comparison logic is the only architectural way to achieve a delta here.
Key takeaway.
A true architect does not just accept full loads as a limitation. By using hash-based comparisons at the database level, you can transform legacy dumps into modern, efficient delta streams.
Exclusive pro tip, the hash column strategy.
Instead of calculating the hash during every load, add a persistent field called record_hash to your DSO. Calculate and store the hash once when data arrives. This makes the next day's comparison even faster because you are comparing two indexed columns rather than calculating values on the fly for millions of rows.
Scenario 36, logistics extraction, the setup table elimination in S/4HANA.
You are migrating a sales to LIS_11_Vatum extractor from an old ECC system to an S/4HANA source. The business wants to know if they still need to perform the painful setup table, filling, transaction V3, which usually requires system downtime. How do you explain the S/4HANA extraction shift?
What most candidates say and why it's weak.
Candidates often say, we still follow the old LO cockpit steps, delete setup tables, fill setup tables, and then run the init. Why this is weak? It ignores the operational data provisioning ODP modernization. S/4HANA, when using ODP as a PI, has optimized the initialization process. While some setup runs might still be needed for historical data, the delta mechanism no longer relies on the old V3 collective runs, which were the main cause of lag in legacy systems.
The interview-winning answer.
In the S/4HANA and ODP era, the logistics extraction architecture has changed significantly. 1. Bypassing V3 in ODP as a PI, the collective run V3 is no longer required for most modules. Data is passed directly to the operational delta queue, ODQ, almost immediately, reducing latency from hours to minutes. 2. Initialization without downtime. We can now perform a delta init while users are still active in the system. The ODQ framework is smart enough to handle serialization, capturing changes that happen during the initial load and merging them correctly. 3. ODP-CDS alternative. For many standard logistics flows, we can bypass the old two LIS extractors entirely and use standard SAP CDS views that support real-time delta via database triggers, eliminating setup tables forever. Here is SQL code showing how to check the ODP operational delta queue, ODQ, for active logistics delta subscriptions. Disclaimer: always test code in a non-production environment. Here is the code block that identifies our sales logistics extractor. This code snippet shows how an architect can verify if the new ODP framework has successfully registered the old 2LIS extractor, proving that the migration from legacy SAPI to modern ODP is functioning correctly. In this code block, we check the delta state. This proves that we are no longer dependent on the old RSA7 green light. Instead, the system shows an active state directly in the database level queue, confirming that changes are flowing without the need for manual V3 job scheduling.
Follow-up 1. Does ODPS API still require a delta queue in the source system, similar to RSA7?
Answer: no. The old delta queue RSA7 is replaced by the operational delta queue ODQ. The ODQ is much more advanced. It supports multiple subscribers, provides built-in data compression up to 90%, and allows for delta recovery without having to refill setup tables.
Follow-up 2. If we use CDS views for sales extraction instead of two LIS extractors, Do we lose any functionality?
Answer: you might lose some of the complex out-of-the-box transformations that SAP spent 20 years building into the two LIS extractors. However, you gain real-time capability and a significantly simpler architecture. The strategic move is to use CDS for new requirements and keep two LIS only for very complex legacy logic.
Follow-up 3 Curveball. You are running a Delta init for sales. A user creates an order during the init. How does ODP ensure that update is not lost or doubled?
Answer: ODP uses serialization. When the init starts, ODP creates a snapshot. Any changes made during the init are held in the ODQ. Once the init finishes, those changes are applied on top of the snapshot. Because the ODQ tracks unique record IDs, there is no risk of doubling the data.
Key takeaway.
S/4HANA has finally killed the batch-only logistics mindset. With ODP, the heavy lifting of setup table management is mostly gone, replaced by a much faster, compression-aware streaming framework.
Exclusive pro tip. The direct Delta setting.
In your interview, mention that you always check the extraction method in S/4HANA LBWE. By switching from Q Delta to direct Delta in an ODP environment, you can bypass the extraction Q, MCEX, tables entirely. This moves data to the warehouse in near real time, without any background job latency.
Scenario 37. SDA versus SDI virtual access versus replication strategy.
You are integrating an external Microsoft SQL server containing historic sales archives into your BW4HANA environment. The archive is 5 terabytes. You need to decide between using Smart Data Access, SDA, for virtualization or Smart Data Integration, SDI, for replication. How do you decide which technology fits this architectural requirement?
What most candidates say and why it's weak.
Many candidates suggest use SDA because virtualization saves storage space. Or they say use SDI because it is the newer version of SDA. Why this is weak: it misses the critical processing power trade-off. SDA is a federation tool. Every time a user runs a report, it puts a heavy query load on the source SQL server. If the source is an old archive with limited CPU, SDA will crash it. SDI is an ETL and replication tool. It is better suited for moving data into BW4HANA for high-performance reporting.
The interview-winning answer.
I would choose based on the data gravity and source system capacity logic 1. Smart Data Access, SDA. I would use this only if the requirement is for occasional lookups or small datasets where zero footprint in BW is the goal. It is a virtual connection that does not persist data. 2. Smart Data Integration, SDI. I would choose this for the 5 terabytes archive. SDI allows for real-time replication and complex transformations via the data provisioning agent. It can persist data in a DSO, moving the processing load away from the source SQL server and onto the HANA database. 3. Decision factor. If the users need sub-second query performance on that 5 terabytes archive, SDA is impossible due to network and source DB latency. Replication via SDI is the only architecturally sound path. Here is SQL code showing how to create a remote source and a virtual table via Smart Data Access, SDA. Disclaimer: always test code in a non-production environment. Here is the code block where we define the external handshake. This code snippet establishes the communication protocol, SDA, between the HANA database and the remote SQL server, defining the adapter and network path. In this code block, we create the virtual table. This code snippet proves that no data is actually being moved yet. We are simply creating a metadata definition that allows BW4HANA to see the remote data as if it were a local table, which is the core of SDA virtualization.
Follow-up 1. SDI requires a data provisioning agent, DPA. Does this agent need to be installed on the BW4HANA server?
Answer: no, absolutely not. The DPA should be installed on a separate server, usually as close to the source system as possible. This minimizes network latency and ensures that the heavy transformation or compression work happens before the data hits the BW4HANA network.
Follow-up 2. When using SDA virtual access, Can we still use BW analysis authorizations to protect the data?
Answer: yes. Since the data is exposed via a virtual provider or open ODS view, BW4 HANA treats it like any other object. You can apply standard analysis authorizations to filter the virtual results based on the user's role, providing a unified security layer regardless of where the data physically sits.
Follow-up 3 Curveball. You have chosen SDI replication. The source system has a network failure mid-load. How does SDI handle the restart?
Answer: SDI supports resumable replication. It uses a checkpoint mechanism. Once the connection is restored, the data provisioning agent looks at the last successful transaction log offset and resumes exactly from where it left off, preventing the need for a full reload of the 5 terabytes dataset.
Key takeaway.
SDA is for viewing data from a distance. SDI is for integrating data into your ecosystem. An architect chooses SDA for agility and SDI for performance and reliability.
Exclusive pro tip, the join pruning rule.
When using SDA virtual tables in a composite provider, always mention join pruning. If you join a virtual table with a local DSO, HANA is smart enough to only trigger the remote SDA query if the user actually requests fields from the remote source. This pruning prevents unnecessary network calls and is the secret to fast virtual modeling.
Scenario 38, cloud connectivity, integrating with SAP Datasphere DWC.
Your organization is adopting a hybrid cloud strategy. They want to keep their core finance logic in BW4 HANA, but move their global marketing analytics to SAP Datasphere. How do you architect a unified data fabric so marketing users can consume finance data without duplicating it?
What most candidates say and why it's weak.
Most candidates suggest extract the BW4 HANA data and load it into Datasphere via a flat file or ODP. Why this is weak? This creates data silos and data drift. By the time the finance data lands in Datasphere, it is already outdated. Furthermore, you lose all the complex logic you built in your BW4 HANA query, calculated key figures, restricted key figures. The correct answer must focus on virtual federation, not replication.
The interview-winning answer.
I would implement a model-driven federation strategy using the SAP BW4 HANA Model Transfer Feature 1. BW Bridge/Model Transfer. I would use the standard integration to expose BW4 HANA queries as remote sources in SAP Datasphere. This imports the metadata structures into the cloud without moving the underlying data. 2. Virtual consumption in Datasphere. Marketing users build their views on top of these remote tables. Every time they run a cloud report, it calls the BW4 HANA OLAP engine in real time. 3. Logic preservation. This approach is superior because it preserves all BW query logic. Restricted key figures and currency conversions happen in the source of truth, BW4 HANA, and are simply displayed in the cloud. Here is a JSON configuration snippet representing the connection properties between BW4 HANA and SAP Datasphere. Disclaimer: always test code in a non-production environment. Here is the code block indicating the core strategy. By setting data federation to true, this code snippet proves that we are opting for a live connection rather than a scheduled data load, ensuring real-time accuracy in the cloud. In this code block, we handle hierarchy logic. This code snippet shows how the model transfer bridge ensures that complex parent-child relationships defined in BW4 HANA are automatically understood by the cloud engine, saving weeks of manual remodeling work.
Follow-up 1. If we use virtual federation, will not the performance be slow for marketing users in the cloud?
Answer: it can be, which is why we use intelligent cold caching in Datasphere. We can choose to persist only the aggregate results in the cloud while keeping the line item detail virtual in BW4 HANA. This gives users the speed of the cloud with the depth of the warehouse.
Follow-up 2. What is the SAP BW bridge in Datasphere, and when should we use it?
Answer: the BW bridge is a feature specifically for legacy customers. It provides a dedicated ABAP environment in the cloud to host your old extractors and ODP sources. We use it when we want to retire our on-premise BW hardware entirely, but aren't ready to rebuild our complex extractors in a native cloud format.
Follow-up 3, Curveball. Can we join a BW4 HANA remote table with a local CSV file uploaded to DataSphere?
Answer: yes, that is the primary value of DataSphere. You can create a graphical view that joins your governed finance data, remote from BW, with local, agile marketing data, CSV. The system handles the join at runtime, providing a unified view across hybrid sources.
Key takeaway.
BW4 HANA is no longer a closed box. In the hybrid era, it acts as the resilience and governance layer that feeds the agility and innovation layer of SAP DataSphere.
Exclusive pro tip, the space strategy.
When connecting BW to DataSphere, always recommend using spaces. In an interview, explain how you create a dedicated finance_space that is restricted to certain users, ensuring that while the data is federated to the cloud, the enterprise-grade security of your BW4 HANA system is never compromised.
Scenario 39, Error Handling DTP Error Stacks versus Logical Workspace Management.
You are loading 50 million records into a standard DSO. The load fails at 99% because of 500 records with invalid characters in a customer name field. The business cannot wait for a source system fix. How do you design an error handling strategy that allows the 49.9 million good records to be reported while isolating the bad ones for correction?
What most candidates say and why it's weak.
Most candidates suggest use the DTP error stack and set the error limit to 1,000. Why this is weak? While technically correct for small loads, the error stack in BW4 HANA is an internal technical table. Storing 500+ records from a 50 million record load in the error stack can significantly degrade performance. Furthermore, correcting data in the error stack is a manual, IT-heavy process that does not scale for complex business data quality issues.
The interview-winning answer.
I would implement a fail-safe ingestion architecture using a dedicated staging a DSO for data quality management. 1. DTP configuration. I set the DTP to accept errors and update valid records. This ensures the 49.9 million clean records hit the reporting a DSO immediately. 2. Staging isolation. Instead of using the internal technical error stack, I configure the DTP to route error records into a separate staging a DSO specifically designed for data stewards. 3. Business-led correction. Data stewards use a custom SAP Fiori app or BW workspace to correct the 500 records directly in the staging a DSO. Once fixed, a secondary DTP pushes only the corrected records into the main reporting a DSO. 4. Result. This keeps technical logs clean and puts the responsibility of data content back on the business owners, not the IT team. Here is SQL code showing how to identify records in the technical error stack table for a specific DTP request. Disclaimer: always test code in a non-production environment. In this code block, we target the specific technical table generated for a failed load request. Here is the code block proving that BW4 HANA stores the exact failing packet, allowing an architect to investigate the binary content of the error without interrupting the primary active tables. This code snippet shows how we filter for critical errors only. By identifying the specific record number and field name in this code block, we can automate a data quality report that notifies the business steward exactly which fields require manual intervention.
Follow-up 1. If we update valid records in a standard DSO, what happens to the change log? Is it consistent?
Answer: yes. Only the valid, activated records generate entries in the change log. The error records are never activated in the main DSO, so they never hit the change log. This ensures that downstream deltas remain consistent and only contain business-ready data.
Follow-up 2. The client asks if they can use SAP Information Steward instead of staging a DSO for this. Is that a better solution?
Answer: if the organization has the license, yes. Information Steward is built for cross-system data profiling and cleansing. However, for in-flight errors during a BW load, staging a DSO is more efficient because it stays within the BW4 HANA security and process chain context.
Follow-up 3. Curveball. You have set the error limit to 1,000, but the load receives 1,001 errors. What happens to the records that were already processed?
Answer: the DTP request will fail entirely and perform a rollback of the current package. However, if previous packages in the same request were already committed to the inbound queue, they remain there. To ensure 100% consistency, I recommend using request-level transactional integrity settings to ensure an all-or-nothing load for critical financial data.
Key takeaway.
The technical error stack is for debugging. A DSO is for data quality. Do not force your IT team to fix business data errors. Build an architecture that enables the business to fix themselves.
Exclusive pro tip, the autocorrect routine.
In your interview, suggest adding an autocorrection library in your MDP start routine. For common errors like trailing spaces or lowercase instead of uppercase, do not even send them to the error stack. Fix them in the database layer during the load. This can reduce your manual error handling by 80%.
Scenario 40, Legacy 3.x migration, moving old data sources to ODP context.
During a BW4 HANA migration, you find several critical 3.x data sources, legacy emulated data sources, still in use. You know that BW4 HANA does not support the 3.x flow or info packages. How do you modernize these objects without redeveloping 10 years of logic?
What most candidates say and why it's weak.
Candidates often say, we will just delete them and rebuild everything from scratch, or we will use the standard migration tool. Why this is weak? Rebuilding from scratch is a massive waste of budget and risk. Using the migration tool on a 3.x data source directly often fails because BW4 HANA requires the ODP operational data provisioning framework. You must follow a specific sequence of source system migration, followed by object conversion, to avoid losing delta pointers.
The interview-winning answer.
I would use the BW4 HANA Transfer Cockpit, RSB4 HTRF, following a strict three-step modernization path 1. Source system context. First, I migrate the source system connection from legacy SAP or a LE to the ODP-SAP context. This is the mandatory foundation for BW4 HANA. 2. 7.x migration. I use transaction RSDS to migrate 3.x data source to 7.x while still in the legacy system. This converts the info package logic into DTP-ready logic. 3. ODP registration. Finally, I switch to ODP in the data source settings. This registers the technical data source name in the operational delta queue, ODQ, allowing BW4 HANA to consume the old extractor via the modern ODP protocol. Here is SQL code showing how to verify the registration of a legacy data source in the ODP operational delta queue, ODQ. Disclaimer: always test code in a non-production environment. This code snippet is critical. Here is the code block proving that the legacy SAP service API extractor has been successfully wrapped in the modern ODP framework, which is the only way BW4 HANA can continue to use these old but valuable data sources. In this code block, we target a specific legacy object. This code snippet shows how an architect verifies the metadata handshake between S4 HANA and BW4 HANA, ensuring that the delta pointer for the GL extractor survived the migration process.
Follow-up 1. Do we lose the historical delta when we switch a data source to the ODP context?
Answer: if done correctly via the transfer cockpit, no. The system performs a delta catch-up. It reads the old RSA7 queue and populates the new ODQ queue. However, I always recommend a delta sync, performing a final load in the old environment before executing the switch to be 100% safe.
Follow-up 2. What happens to the info packages associated with the 3.x data sources?
Answer: info packages are deleted. They are no longer needed because ODP-based data sources are triggered directly by DTPs. Any selection logic that was in the info package must be moved into the DTP filter or the process chain variant.
Follow-up 3. Curveball. You have a 3.x data source that uses a customer exit for its delta. Does ODP support this custom ABAP logic?
Answer: yes. ODP is just a transport layer. The underlying extractor logic in the source system, the function module or view, remains untouched. As long as the 3.x data source is properly migrated to the 7.x/ODP structure, your custom ABAP exit code will continue to run exactly as it did before.
Key takeaway:
Modernizing legacy 3.x objects is a prerequisite for BW for HANA. The goal is to move every data stream into the ODP framework, creating a single, high-performance handshake between all SAP systems.
Exclusive pro tip: the shadow data source.
If a 3.x data source is too complex to migrate, create a shadow ODP-CDS view on the underlying tables in the source system. This allows you to bypass the old SAP logic entirely and build a future-proof, real-time stream that is native to BW for HANA.
Part 2 conclusion: the veins are flowing.
We have now mastered the veins of the system. We know how to ingest data using ODP-CDS, how to stream records in real time, and how to handle complex unstructured sources via SLT. Your architecture can now feed the warehouse at the speed of business.
But data is heavy.
However, ingesting 100 million records is only half the battle. If your end users wait 5 minutes for a report to run, or if your nightly loads fail due to memory overflows, your architecture has failed. A model without performance is just expensive storage.
Please check description or comment section of this video. I have given a lot of links for downloading 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked, system design, most asked implementation project-related questions and answers, support project-related questions and answers. Required for your SAP technical modules interviews jobs like SAP Basis admin jobs, SAP S4 HANA consultant jobs, SAP ABAP developer jobs, SAP ABAP OData developer jobs, SAP Fiori UE5 developer jobs, SAP ABAP HR consultant jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people. Also for your interviews, you people can download all 8 PDFs in a single zip file from below given links.
Part 3: the muscle, performance and engineering.
This brings us to the final and most critical phase, the muscle. This section covers the hard engineering required to make BW for HANA fly. We are talking about code pushdown, database partitioning, migration strategies, and deep system administration. This is where you prove you understand the HANA engine underneath the application.
The final 10 scenarios.
In this final section, we will dissect the following high-stakes engineering challenges. 41. HANA pushdown, replacing ABAP loops with a MDP and SQL script. 42. Query performance, debugging calculation views versus OLAP processor bottlenecks. 43. Partitioning strategy, when to use hash versus semantic partitioning for massive tables. 44. Migration paths, the strategic decision between shell versus remote conversion. 45. Transport management, handling object dependencies in a mixed model landscape. 46. Inventory deep dive, the specific architecture for non-cumulative key figures. 47. Currency conversion, optimizing exchange rates at the database level. 48. Authorizations, mapping BW analysis auth to native HANA privileges. 49. Housekeeping, managing change log growth and active table compression. 50. Future-proofing, Architecting models for seamless consumption in SAP Analytics Cloud, SAC. Let's finish strong. Scenario 41, the art of code pushdown.
Scenario 41, HANA pushdown, replacing ABAP loops with a MDP.
You have a transformation that calculates customer lifetime value for 50 million records. The current ABAP start routine uses a loop-at statement to aggregate sales history. It takes 4 hours to run. How do you re-architect this logic to run in under 5 minutes on BW4 HANA?
What most candidates say and why it's weak.
Candidates often say, I will optimize the ABAP code using hash tables and field symbols. Why this is weak? This is ABAP thinking, not HANA thinking. No matter how optimized the ABAP is, you are still moving 50 million records from the database server to the application server to process them. This data movement is the bottleneck. The only architectural solution is code to data, pushing the logic down to the database.
The interview-winning answer.
I would replace the ABAP routine with an MDP, ABAP Managed Database Procedure, using SQL Script 1. Eliminate data transfer. By wrapping the logic in an MDP class, the calculation happens entirely inside the HANA memory. The application layer receives only the final result. 2. Set processing. I replace the iterative loop logic with declarative select and group by statements. HANA's calculation engine is optimized for these vector operations. 3. Implementation. I would create a HANA expert script in the transformation, calling the MDP method to perform the aggregation and currency conversion in a single database pass. Here is the SQL script. A MDP logic replacing a slow ABAP loop with a high-performance database aggregation. Disclaimer, always test code in a non-production environment. This single SQL block replaces hundreds of lines of ABAP looping code. Instead of processing row by row, HANA processes entire columns in parallel. This is why the runtime drops from 4 hours to minutes. The heavy lifting is done where the data lives.
Follow-up 1. Can we call an MDP inside a standard BW transformation start routine?
Answer, yes, but you have to wrap it in ABAP. The start routine is still ABAP-based. You would define a standard ABAP class that implements the if_amp_marker_HDB interface. Write the SQL script inside a method and call that method from your start routine.
Follow-up 2. What is the downside of using a MDP? When should we stick to ABAP?
Answer, a MDP is black box to the ABAP debugger. You cannot step through it line by line using standard ABAP tools. You need the HANA debugger, a DT. Also, if the logic requires complex row-by-row procedural checks, like parsing a messy text string, that SQL handles poorly, standard ABAP might actually be faster or easier to maintain.
Follow-up 3. Curveball. You used a MDP, but the performance is still slow. You check the trace and see a materialization step. What does that mean?
Answer, it means the HANA optimizer failed to unfold the query and had to create a temporary table in memory to store intermediate results. This often happens if you use imperative logic loops or vars inside SQL script instead of declarative logic select. The fix is to rewrite the SQL script to be purely declarative.
Key takeaway.
ABAP is for process orchestration. SQL script is for data crunching. Knowing when to switch languages is the hallmark of a BW4 HANA architect.
Exclusive pro tip. The HANA expert script rule.
In BW4 HANA transformations, if you create a HANA expert script, you completely bypass the standard transformation mapping. This is powerful but dangerous because you lose the metadata lineage. Use it only when the standard graphical mapping cannot achieve the required pushdown performance.
Scenario 42. Query performance, debugging the OLP versus database bottleneck.
A CFO's dashboard report takes 45 seconds to load. You need to identify if the slowness is caused by the HANA database, fetching the data, or the BW-OLP processor, calculating complex formulas. Which tools do you use and how do you interpret the results?
What most candidates say and why it's weak.
Most candidates say, I will check the index on the DSO or I will use transaction SM50 to check the work process. Why this is weak? SM50 only tells you that something is running, not what is slow. Checking indexes is legacy thinking. HANA columns are already indexed. To fix a 45-second delay, you need granular trace data that separates the database layer from the application layer.
The interview-winning answer.
I would perform a structured performance trace using RSRT in HANA Plan Viz 1. RSRT Query Monitor. I run the query with execute plus debug and enable performance statistics. This breaks down the runtime into DB time versus OLP time. 2. Diagnosis. If DB time is high, for example 40 seconds, the issue is a heavy join or lack of pruning in the HANA view/provider. If OLP time is high, the issue is excessive exception aggregation or formula collision in the query definition. 3. HANA Plan Viz. If the DB is the culprit, I generate a Plan Viz file. This visualizes the execution path, showing me exactly which join node or calculation is consuming the most memory. Here is a visualization of the RSRT trace output, identifying an OLP bottleneck. Disclaimer: always test code in a non-production environment. Here is the critical metric. This line proves that HANA is doing its job perfectly, retrieving the dataset in half a second. Any tuning done at the database level, indexing, partitioning, would be a waste of time. This line identifies the true smoking gun. The application server is struggling to compute a complex aggregation, like count distinct or first value, on the result set. The fix involves pushing this logic down to a HANA calculation view or simplifying the query structure.
Follow-up 1. You found that exception aggregation is the bottleneck. How do you fix it?
Answer: we enable exception aggregation pushdown. In the query properties, or the underlying HANA view, there is a setting to force this calculation to happen in the HANA engine rather than the ABAP OLP engine. This leverages the massive parallel processing of HANA.
Follow-up 2. The trace shows high data transfer time, network load. What causes this?
Answer: this happens when the database returns too many rows to the application server. For example, 5 million rows, which are then filtered or aggregated locally. The fix is to ensure all filters and aggregations are applied before the data leaves the database, reducing the result set size.
Follow-up 3. Curveball. Can Plan Viz help us debug a standard BW query?
Answer: Plan Viz is for HANA views. However, since every BW query eventually generates a TREX, HANA SQL statement, we can capture that generated SQL statement in RSRT and run it in HANA Studio to produce a Plan Viz file. This gives us the deep database level breakdown of a standard BW artifact.
Key takeaway.
Do not guess, trace. The separation of DB time and OLP time is the single most important metric for performance tuning in BW for HANA.
Exclusive pro tip: the operations mode check.
In RSRT, check the operations mode of the query. If it says standard, some logic is running in ABAP. If it says TrexOps, the logic has been successfully pushed down to the HANA engine. Always aim for TrexOps for maximum performance.
Scenario 43. Partitioning strategy semantic versus hash for 2 billion records.
You are modeling a point of sale, a DSO that will hold 2 billion records. The client demands both fast data loads, parallel inserts, and fast reporting, query pruning. A standard fiscal year partition is not enough because the monthly volume is too high, 150 million records per month. How do you partition this table?
What most candidates say and why it's weak.
Candidates often say, I will partition by fiscal year per month, range partitioning. Or I will use hash partitioning on the document number. Why this is weak? Using only range partitioning leads to skewed partitions. 1 month might have 200 million records, making it too fat for a single node to process efficiently. Using only hash partitioning gives great insert speed, but destroys reporting performance because the database has to scan every partition for a simple date query. No pruning.
The interview-winning answer.
I would implement multi-level partitioning. Hash range 1. Level 1 hash. I partition by hash on the document number or highly granular key with 16 or 32 partitions. This ensures parallel inserts and even data distribution across all HANA nodes. Load balancing. 2. Level 2 range. Inside each hash, I subpartition by range on 0, This enables partition pruning. When a user runs a report for March 2024, HANA knows exactly which subpartitions to read and ignores the rest. 3. Result, we get the write speed of hash and the read speed of range. Here is the HANA SQL syntax for altering in a DSO table to use multi-level hash range. Partitioning. Disclaimer, always test code in a non-production environment. This first level handles the write performance. By hashing the document number into 16 separate buckets, we allow 16 parallel threads to write simultaneously without locking the table. This second level handles the read performance. This code block creates the time slices. If a query requests data for Jan 2024, the database engine will skip every partition except the one defined in the first range, scanning only a fraction of the 2 billion records.
Follow-up 1. What is the maximum number of records recommended per partition in HANA?
Answer, the soft limit recommendation is usually 2 billion records per table or partition due to the integer limit of row IDs. But for performance, we aim for 50 to 200 million records per partition. Anything larger starts to degrade the delta merge performance and memory loading times.
Follow-up 2. You enabled multi-level partitioning, but the pruning is not working in the query trace. Why?
Answer, this happens if the query filter does not match the partition key exactly. If you partition by 0 month but the user filters by 0 call day, HANA cannot prune effectively because the partition metadata is at the month level. The query filter must align with the physical partition structure.
Follow-up 3. Curveball. How do we handle dynamic partitioning for future years? Do we have to manually alter the table every year?
Answer, yes. Standard partitioning is static. However, in BW for HANA, we can use the dynamic partitioning setting, based on a pattern, or schedule a background job that executes the alter table add partition script automatically at the end of the year to prepare for the new fiscal periods.
Key takeaway.
Partitioning is not just about storage size. It is about query pruning. If your partition strategy does not align with your user's common filter patterns, for example time, you are wasting the feature.
Exclusive pro tip, the group strategy.
For massive tables, ensure your partition table is distributed across different HANA host groups if using a scale-out architecture. This physically spreads the I or O load across different server blades, preventing one server from hitting 100% CPU during a heavy report.
Scenario 44, migration strategy, shell conversion versus remote conversion.
A client is running BW 7.4 on Oracle. They want to move to BW for HANA. They have 10 years of history, 20 terabytes, but 80% of the old data models are junk, deprecated, or unused. They want a clean core but need to retain historical data. Which migration path do you choose?
What most candidates say and why it's weak.
Most candidates say, use remote conversion because it migrates the data for you, or use in-place conversion to keep everything. Why this is weak? Remote conversion forces you to migrate the data structure as is, risking carrying over bad designs. In-place is impossible here because the source is on Oracle. BW for HANA requires HANA. It also fails the clean core requirement because it upgrades the junk along with the good.
The interview-winning answer.
I would recommend a shell conversion strategy to ensure a clean core one. Metadata only, shell conversion copies only the object definitions, InfoCubes to a DSOs to the new BW for HANA box. It brings 0 data and 0 junk. 2. Selective data transfer. Since we only need 20% of the models, we select only those for the shell transfer. The junk is left behind. 3. Historical load. For the 20 terabytes of history, we connect the new BW for HANA system to the old BW 7.4 system using ODP. We load the historical data selectively into the new, clean DSOs. Here is the scope transfer comparison, logic used during a shell conversion decision. Disclaimer, always test code in a non-production environment. This XML snippet represents the strategic decision. By explicitly flagging legacy technical debt as skip, we ensure the new system starts lean. This is the primary advantage of shell conversion over in place. We have total control over what enters the new environment. Here, we convert the structure but leave the data behind. This allows us to optimize the new ADSO, for example, adding partitions or changing keys, before we load the 20 terabytes of history, preventing the performance issues inherent in the old design.
Follow-up 1. If we use shell conversion, how do we load the historical data? Do we need flat files?
Answer: no. We connect the new BW4 HANA system to the old BW 7.4 system as a source system, ODP-BW. BW4 HANA treats the old InfoCubes as data sources. We simply create a transformation and DTP to pull the data directly from the old system over the network.
Follow-up 2. What is the risk of remote conversion for 20 terabytes of data?
Answer: downtime and network latency. Remote conversion relies on the SUMDMO tool, which moves data during the upgrade phase. Moving 20 terabytes over the wire can take days, during which the system is locked. Shell conversion allows you to go live with the structure immediately and load the history in the background while the system is up.
Follow-up 3. Curveball. We have 3.x data flows in the 7.4 system. Can shell conversion handle them?
Answer: no. The transfer cockpit requires 3.x flows to be migrated to 7.x flows before conversion. You must perform the RS migrate step in the source system first, or redesign the flow from scratch in the new BW4 HANA system, which is often cleaner.
Key takeaway.
In place is for small, simple systems. Remote is for lift and shift. Shell conversion is for re-architecture and clean core. For enterprise clients, shell is almost always the correct answer.
Exclusive pro tip, the carve-out strategy.
If the client has multiple BW systems regional, use shell conversion to consolidate them. You can import the shell metadata from System A, then System B, merge them into a single global data model in BW4 HANA, and then load data from both. This effectively turns a migration project into a consolidation project.
Scenario 45, transport management, handling mixed architecture dependencies.
You have built a mixed scenario model. It consists of a BW4 HANA composite provider that joins a standard DSO with a native HANA calculation view. When you release the transport request, SE01, the deployment fails in queue because the HANA view is missing. How do you architect a transport strategy that keeps a BAP, BW, and native HANA objects in sync?
What most candidates say and why it's weak.
Candidates often say, I will manually import the HANA delivery unit, DU, first, then the BW transport. Why this is weak: manual synchronization is a recipe for disaster in enterprise landscapes with frequent releases. If the versions drift even slightly, the composite provider activation will fail. A principal architect uses bundled lifecycles to ensure atomicity.
The interview-winning answer.
I would implement the HANA Transport Container, HTC strategy within the BW4 HANA Transport Framework 1. The container object, I create a logical HANA Transport Container object in BW. I assign the specific HANA calculation views and packages to this container. 2. Unified T-logo, when I collect the composite provider in the BW Transport Connection, RSA1, I also collect the HTC. This wraps the native HANA code inside the standard BW transport request. 3. Atomic deployment. When the transport moves to QA, the system unpacks the HTC and deploys the HANA views before activating the BW composite provider. This guarantees dependency resolution without manual intervention. Here is an XML representation of a BW transport request containing a HANA transport container, HTC. Disclaimer: always test code in a non-production environment. This tag represents the HTRC, HANA transport container, T-logo object. It proves to the interviewer that you know the specific object type required to bridge the gap between the ABAP application layer and the HANA database layer. By nesting the native view inside the BW object list, we ensure that the lifecycle manager, HALM, is triggered automatically during the ABAP import phase, deploying the database views exactly when the application needs them.
Follow-up 1. Does the HTC approach work if we are using HDI containers, HANA deployment infrastructure, instead of the old repository?
Answer: yes, but the mechanism changes. With HDI, we use the SAP Web IDE or Business Application Studio to build the project. The deployment creates an MTA multi-target application archive. In a pure DevOps pipeline, we might separate the HDI deploy from the BW deploy, but for tight coupling, We still map the HDI container to the BW project scope.
Follow-up 2. What happens if the HANA view activates, but the composite provider fails validation in QA?
Answer: this usually happens due to column mismatch. If a column was renamed or typed differently in the HANA view, the composite provider metadata becomes invalid. I would check the index server trace logs to find the specific SQL error and re-import the metadata in the BW modeling tools.
Follow-up 3. Curveball. Can we transport personalized data, like specific variable values, using this method?
Answer: no. Transports are for metadata structure, not master data content. If you need to move configuration data, like TVARVC entries or specific mapping table rows, you must put the table keys in a workbench request or use a separate data load. Mixing data and structure in one transport is an anti-pattern.
Key takeaway.
In a mixed scenario, hope is not a strategy. You must use a HANA transport container or a unified CI/CD pipeline to ensure that your database artifacts arrive before your application logic tries to consume them.
Exclusive pro tip. The source system dependency.
When transporting open ODS views, remember that the source system connection in RSA1 is a dependency. If the QA system points to a different schema name than dev, the open ODS view will fail. Use source system mapping in the transport routes, SDMS, to auto-switch the schema pointers during import.
Scenario 46. Inventory handling non-cumulative key figures. NCKF deep dive.
You are modeling a material stock report. The user wants to see inventory levels for any day in the past 5 years. The source system only sends movements, goods issue, or receipt. If you model this as a standard cumulative SUM, the query will be painfully slow calculating 5 years of math for every row. How do you architect this for sub-second response?
What most candidates say and why it's weak.
Candidates often say, I will create a snapshot of DSO and load the stock balance every night. Why this is weak? This explodes storage. Storing the balance of 1 million materials every day for 5 years equals 1.8 billion records. It is wasteful and redundant. Furthermore, if you miss a nightly load, your history is broken forever.
The interview-winning answer.
I would use the BW4 HANA inventory, non-cumulative, capabilities within a standard ADSO1. Non-cumulative flag, I mark the ADSO as inventory enabled. This changes the physical table structure in HANA. 2. Validity table, BW4 HANA automatically generates a validity table that tracks the time slices for which a stock value is valid. 3. Marker updates instead of storing every day. The system stores reference points markers. When a user queries a date, the HANA engine takes the nearest marker and adds or subtracts only the relevant movements, deltas, to compute the value on the fly. 4. Result, we store 1% of the data, movements plus markers, but get 100% of the historical visibility. Here is SQL code showing the specialized validity table structure, generated for inventory, ADSOs. Disclaimer: always test code in a non-production environment. This table is unique to inventory ADSOs. It defines the time validity of a record. Without this, the database would not know which stock value applies to March 15th if the last movement was on March 10th. This explains the HANA pushdown benefit. The database engine finds the closest marker, for example, end-of-month balance, and only sums the few movements that happened after that marker. This is millions of times faster than summing all movements from the beginning of time.
Follow-up 1. We loaded historical movements for the last 5 years, but the current stock is wrong. Why?
Answer: you likely missed the initialization 2LIS_03_BX. Inventory requires an opening balance. Without an initial stock level, even if it is 0, the math has no starting point. You must load the opening stock first, compress it with the marker update flag, and then load the historical movements.
Follow-up 2. Can we use the inventory ADSO for performance-intensive write operations, like high-frequency IoT?
Answer: no. The overhead of maintaining the validity table and markers makes writing slow. Inventory ADSOs are optimized for read querying history, not write. For high-frequency ingest, use a write-optimized ADSO first, then aggregate into the inventory ADSO.
Follow-up 3. Curveball. How do you handle retroactive updates, for example, a correction posting for last year?
Answer: the system handles this automatically via the change log. When a retroactive record arrives, the DSO updates the movements table. Crucially, the next time the validity table is updated, during compression or activation, the system recalculates the markers for all subsequent periods to reflect the change.
Key takeaway.
Inventory modeling is the ultimate test of virtual versus physical thinking. We physically store movements and markers, but we virtually calculate the stock at time t. Never try to build this logic manually with standard DSOs.
Exclusive pro tip: the zero record mode filtering.
When dealing with inventory extractors, 2LIS_03_BF, ensure your transformation correctly maps zero record mode. If you map after images incorrectly, you will double count stock. Always use the standard SAP content transformation logic for zero record mode to handle cancellations. Storno correctly.
Scenario 47, currency conversion, HANA view versus BW transformation.
You are building a global sales report for a CEO who needs to switch between USD, EUR, and local currency on the fly. You have 500 million records. Should you perform the currency conversion during the data load, transformation, or during the query execution, reporting layer? What is the architectural impact?
What most candidates say and why it's weak.
Most candidates say, do it in the transformation so the query is fast. Why this is weak: pre-calculating currency locks you into a specific exchange rate date, usually the booking date. If the CEO wants to see what if we use today's rate versus last month's rate, your persisted data is useless. Storing multiple currencies also triples your storage costs, 1.5 billion records instead of 500 million.
The interview-winning answer.
I would implement query time conversion pushed down to the HANA database. 1. Storage efficiency: we store only the local currency in the ADSO. This keeps the table size at 500 million rows. 2. Agility: we utilize the currency translation type in the composite provider or query. We enable the HANA pushdown flag for this translation type. 3. Performance: the HANA engine calculates the conversion on the fly using the convert_currency SQL function. Because HANA keeps the TCUR exchange rate tables in memory, this calculation adds negligible overhead, even for millions of rows. Here is the SQL script syntax used by HANA to perform high-speed currency conversion on the fly. Disclaimer: always test code in a non-production environment. This is the native HANA function that replaces the old ABAP function modules. It reads directly from the TCURR, tcurcs, and tcurve tables in the database kernel. By invoking this, we avoid moving data to the application layer for math, keeping the operation strictly within the database engine. In a report with 500 million rows, one missing exchange rate should not crash the dashboard. This parameter ensures that if a rate is missing for a specific date, that single row returns null instead of throwing a generic database error, allowing the rest of the report to render correctly.
Follow-up 1. We are using a mixed scenario, composite provider joining a HANA view. The TCUR tables are in the BW schema, but the HANA view is in a different schema. How does the conversion find the rates?
Answer: we must create synonyms. The HANA view needs visibility to the TCUR tables. We create a synonym in the HANA view's container pointing to the ABAP schema's TCUR tables. We also need to grant select privileges on the TCUR tables to the _sys_repo user or the container user.
Follow-up 2. The client wants to see simulation rates, for example, budget rate 2025, that do not exist in standard SAP tables. How do you handle this?
Answer: I would create a custom rate type, for example, ZBUD, in configuration OB07. We maintain these specific rates in the standard TCURR table. In the query, we create a variable allowing the user to select the exchange rate type at runtime, dynamically switching between standard M rate and budget ZBUD rate.
Follow-up 3. Curveball. Why would you ever choose to persist the converted currency in the ADSO transformation level?
Answer: only for legal compliance or frozen history. If a financial report was signed off in 2020 using a specific rate, We must guarantee that it never changes, even if someone updates the historical exchange rate table today. In this case, persisting the value is a compliance requirement, not a performance choice.
Key takeaway.
Currency conversion is expensive only if you move the data. If you keep it in HANA, it is free. Always default to query-time conversion unless legal requires otherwise.
Exclusive pro tip, the inverse trap.
When configuring translation types, be careful with the inverse exchange rate setting. If you do not maintain pairs, USD to EUR and EUR to USD, HANA might try to mathematically invert the rate, 1/rate. This creates rounding errors in financial reporting. Always insist on maintaining explicit rates for both directions in TCURR.
Scenario 48. Authorizations, mapping BW analysis auth to native HANA privileges.
You have a mixed scenario where data is consumed via BEX queries, BW, and Tableau, direct HANA view. You have complex row-level security, for example, user A sees only Germany, user B sees USA. How do you ensure security is identical in both tools without maintaining two separate security models?
What most candidates say and why it's weak.
Candidates often say, I will build analysis authorizations RSecAdmin for BW and analytic privileges for HANA manually. Why this is weak? Double maintenance is a security risk. If you update a user in BW but forget HANA, you have a data leak. Manual synchronization is not an enterprise-grade solution. You need an automated mapping strategy.
The interview-winning answer.
I would implement the generated analytic privileges approach to create a single source of truth. 1. Source of truth. We define all row-level security in BW for HANA using standard analysis authorizations, RSecAdmin, because it is richer and integrates with HR or org structures. 2. Replication. We enable the external SAP HANA view property on the ADSO or composite provider. In the settings, we flag generate SAP HANA analytic privileges. 3. Runtime. When the HANA view is generated, the system automatically creates a matching SQL analytic privilege. When a user queries via Tableau, HANA looks up their BW authorizations mapped to their database user, ensuring identical results. Here is the SQL syntax for a structured privilege, which BW generates automatically in the background. Disclaimer, always test code in a non-production environment. This where clause is what filters the data at the deepest database level. By having BW generate this SQL automatically based on the info object authorization 0BI_all, we ensure that a user connecting via SQL Tableau or Power BI is restricted by the exact same logic as a BEX query user.
Follow-up 1. To make this work, the BW user ID must match the HANA database user ID. How do we sync them?
Answer, we use the DBMS user mapping in transaction SU01. We map the BW ABAP user, for example, JSmith, to the HANA DB user, for example, JSmith_DB. When the replication job runs, it assigns the generated privileges to the mapped database user.
Follow-up 2. What if the security logic is too complex for standard BW auth? For example, hierarchy-based plus time-dependent.
Answer, in that case, standard generation might fail or be too slow. We would implement a HANA exit procedure, info procedure. We write an SQL script procedure that dynamically determines the user's rights at runtime and assign this procedure to the analytic privilege. This gives us infinite flexibility.
Follow-up 3. Curveball. A user has full access in BW 0BI_all, but sees no authorization in Tableau. Why?
Answer, the 0BI_all star or all access in BW does not automatically translate to a select privilege in HANA for security reasons. You must explicitly grant the _sys_bi_cp_all privilege or ensuring the generated privilege for the specific view includes an empty filter. Allow all condition.
Key takeaway.
Security must be defined in one place. In a BW4 HANA-centric landscape, BW is the master. Use the automated generation features to push that security down to HANA, never the other way around.
Exclusive pro tip. The analysis auth variable.
If you are building native HANA calculation views manually, you can still leverage BW security. Use the session variable $client and $user in your HANA view. Filter expression to look up a custom authorization table maintained by BW. This mimics standard security without the generated overhead.
Scenario 49. Housekeeping managing change log growth.
Your HANA database size has exploded. An analysis shows that 60% of the storage is consumed by change logs /BIC/A, CL of standard DSOs. The client wants to reclaim space immediately without losing the ability to reload data targets. How do you architect a sustainable housekeeping strategy?
What most candidates say and why it's weak.
Most candidates say, I will manually delete the old requests from the manage screen. Why this is weak: manual deletion is risky and unscalable. If you delete a request that has not been propagated to the next layer, you break the delta chain. Furthermore, keeping change logs forever just in case is a lazy architecture that costs thousands of dollars in RAM.
The interview-winning answer.
I would implement a request housekeeping strategy using process chains. 1. Propagation verification. Before deletion, the system must verify that the request has been successfully updated to all downstream targets, data marts. 2. Change log deletion. I configure a recurring process chain step clean up old requests to keep only the last 30 days of change log history. Once data is propagated, the change log is redundant. 3. Active table compression. For the active table, I enable condense, formerly compression, to merge the delta requests into the main table state, reducing the memory footprint by removing technical request IDs. Here is SQL code to identify the largest change log tables consuming HANA memory. Disclaimer: always test code in a non-production environment. This filter targets the specific naming convention of change log tables in BW for HANA. By running this against the HANA system views, we identify exactly which DSOs are bleeding storage, allowing us to target our housekeeping efforts where they save the most money. We query the column store statistics directly. This provides the physical size in RAM, which is the metric that matters for licensing and hardware sizing, rather than just the logical row count.
Follow-up 1. If we delete the changelog, how do we reload the data if the target DSO gets corrupted?
Answer: we rely on the active table or the source system. The change log is for delta calculation, not long-term storage. If we need a full reload, we should reload from the persistent staging area, PSA if available, or re-extract from the source. For critical history, we should have a corporate memory layer, write-optimized, which retains history cheaply on disk.
Follow-up 2. What is the difference between activation and condensation compression in a DSO?
Answer: activation moves data from the inbound queue to the active table and generates the change log. Condensation merges the records within the active table, removing the request ID dimension. Condensation makes the table smaller and faster to read, but you can no longer delete individual loads easily.
Follow-up 3. Curveball. Can we move the changelog to warm storage extension node to save money without deleting it?
Answer: yes. We can configure the data tiering optimization, DTO, settings to place the change log partition on the extension node disk-based memory. This keeps the data accessible for delta processing, but moves it out of the expensive hot RAM.
Key takeaway.
A healthy BW4 HANA system is a clean system. Automated housekeeping is not optional. It is a mandatory part of the architecture to prevent out-of-memory OOM crashes.
Exclusive pro tip. The RSO_HK transaction.
Memorize the transaction code RSO_HK, housekeeping task list. In an interview, mentioning this proves you know the standard SAP toolset for automating cleanup tasks, rather than writing custom ABAP reports to delete tables.
Scenario 50. Future-proofing. Architecting for SAP Analytics Cloud, SAC.
You are building a BW4 HANA model today, but the roadmap says the front end will move to SAP Analytics Cloud, SAC, next year. How do you design your query and provider layers differently to ensure high performance with SAC's live connection?
What most candidates say and why it's weak.
Most candidates say, I will just expose the BW query to SAC. Why this is weak: while technically possible, SAC behaves differently than Beck's analyzer. SAC generates complex MDX or INA queries. If you rely on exit variables, cell definitions, or complex ABAP virtual key figures in your query, SAC performance will crawl. A lift and shift of old queries often fails in the cloud.
The interview-winning answer.
I would adopt a back-end-heavy, front-end light strategy one. Materialize logic. I move complex calculations, for example, year-over-year growth out of the query and into the HANA calculation view or composite provider using calculated columns. This ensures the math happens in the DB, not the browser. 2. Avoid ABAP exits. SAC creates many parallel calls. ABAP customer exits serialize these calls. I would replace ABAP variable exits with HANA exit procedures or standard time dimensions. 3. Annotation-based modeling. I would use CDS annotations or query properties to define formatting and labels in the backend, ensuring SAC picks them up automatically without manual front-end formatting. Here is the annotation logic ensuring a BW query is optimized for SAC consumption. Disclaimer: always test code in a non-production environment. By tagging the query as an analytics object exposed via OData or INA, we enable the high-speed HTTP interface that SAC uses. This bypasses the legacy OLAP BAPI interface, reducing the serialization overhead of the connection.
Follow-up 1. Should we use import mode or live connection for SAC with BW4 HANA?
Answer: for 500 million records, live connection is mandatory. Import mode has row limits, for example, 1 million rows. Live connection leaves the data in BW4 HANA and only brings the aggregated view to the cloud, leveraging the HANA engine's power.
Follow-up 2. We have hierarchy nodes containing formulas in BW. SAC does not show the correct values. Why?
Answer: SAC handles hierarchy post-aggregation differently than BEX. Formula collisions on hierarchy nodes are a known limitation. I would resolve this by pushing the formula down to a calculated key figure in the composite provider, so it calculates correctly at the leaf level before aggregation.
Follow-up 3. Curveball. Can SAC combine BW4 HANA data with Salesforce data?
Answer: yes. We can use smart blending in SAC. However, for performance, it is architecturally better to ingest the Salesforce data into BW4 HANA or DataSphere first and join it there. Browser-based blending in SAC is slow for large datasets.
Key takeaway.
The era of thick front-end logic is over. To future-proof for SAC, your BW4 HANA model must do 99% of the work. The cloud should only render the pixels.
Exclusive pro tip: the geospatial prep.
If your client plans to use SAC geomaps, ensure your BW4 HANA info objects for country or region have the geographical type property set. This allows SAC to automatically recognize them as map coordinates without manual lat or long mapping.
The architect's transformation.
You have just navigated 50 of the most complex, high-stakes scenarios in the SAP ecosystem. You did not just learn how to build in a DSO, you learned how to architect for scale, speed, and stability.
What you now possess.
This series has equipped you with the mental models of a principal architect. 1. The brain. You can design LSA++ models that balance write optimization with read performance. 2. The veins. You can architect robust ODP and streaming frameworks to feed the beast. 3. The muscle. You can engineer SQL script pushdowns and partitioning strategies to crush latency.
Final words.
The next time you walk into an interview, do not just answer the question. Frame the architecture, identify the constraints, deliver the solution. That is what separates a consultant from an authority. If you are ready to lead the next generation of SAP analytics, hit subscribe. Welcome to the architect level.
Please check description or comment section of this video. I have given a lot of links for downloading 8 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked, system design, most asked implementation project-related questions and answers, support project-related questions and answers. Required for your SAP technical modules interviews jobs like SAP Basis, admin jobs, SAP S/4 HANA Consultant Jobs. SAP ABAP Developer Jobs. SAP ABAP O Data Developer Jobs. SAP Fiori UE5 Developer Jobs. SAP ABAP HR Consultant Jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people. Also for your interviews, you people can download all 8 PDFs in a single zip file from below given links. For more exciting tips, tricks and more importantly, for valuable insights of interviews, please share, like, and subscribe to my channel. It has a lot of valuable information about various insights of interviews. It has a wide range of real-world portfolio projects of various technologies for interviews, and it has wide range of most asked interview questions and answers of various technologies like data science, SAP, AWS, DevOps, and full-stack web development and more that will be useful during interviews. It has a wide range of most asked interview questions and answers and real-world portfolio projects of various technologies for freshers, for 2 to 3 years, experienced candidates, and for 5 or above years, experienced candidates to test their skills by knowing most asked interview questions and make themselves ready for interviews.